हेलो हेलो। हाँ जी।
शेखर को दिए। अच्छा ठीक है, एक मिनट आया प्लान। चौहान साहब गुड मॉर्निंग।
गुड मॉर्निंग। हेलो।
हाँ जी सर, यूट्यूब का लिंक मिला है आपको?
हाँ वो मैडम ने भेजा है व्हाट्सएप पे, उससे करें ज्वाइन?
नहीं, वो तो जस्ट चेक करने के लिए यूट्यूब पे भी है ना स्ट्रीमिंग।
वो मिल गया है लिंक मेरे को, इस पे व्हाट्सएप पे भेजा है।
चल शेखर को भेजता हूँ मैं चेक करने के लिए ना।
भेज दे।
हाँ जी नमस्कार मैम। नहीं मैं सुधा से टेस्ट कर रहा था। बस कर दिया, आप कर दिया। दवाई लानी है इधर, जब ज़्यादा लगता है उतर लीजिए ना। ये ग्लास पे स्प्रे है ना?
कौन सा
स्प्रे ने लास्ट वाली है ना?
छेमी के सतमी छेमी सतमी
ये पल कुछ
ले जंदे आ ले जंदी हो आगे रूम
सतमा दिखने क्या छेमी स्प्रे तो नहीं लानी ना।
हां
ये दिखने क्या है ना?
सतमी के आठवीं
सतमी स्प्रे है ना? ये तो नहीं लियानी भी।
हां
ये अठवीं दवाई है कि छोड़ लिखे हुए ना।
अच्छा
मेन ये नहीं ये है ना चौथी के पंजवीं।
चौथी पंजवीं के आठवीं पूछ लानी क्या है?
हाँ
अच्छा
ये है रहने इंट्राकर्नोजोल भी रहने ना। चौथी के पंजवीं का लास्ट दिखने क्या है ना? तो ये ऑनलाइन कर देंगे, ऑनलाइन करेंगे अपने पास। फिर माइक ऑफ
तुम भी तो आ सर
हेलो। मैं इससे करता हूँ, बाहर से करता हूँ फोन आपको, मोबाइल से। चलिए ऑनलाइन स्ट्रीमिंग है। हेलो।
Joined. Joined.
Good morning to all of you. This is Dr. Pradeep Singh. Hello. Are you able to hear me?
Yes, sir.
Good morning, sir.
Thank you everyone for joining this event. Good morning. Good morning. Director sir, no, sir is joining. Then we will start with the proceeding of this course. Just for a few minutes. Good for a few minutes. Thank you.
आज एक हफ्ते तक असेंबली भी चलेगा। जो यूनिवर्सिटी के डायरेक्टर है वो 2 घंटे का
Good morning, sir.
Good morning to all.
Morning, sir.
Good morning, everyone.
Good morning. Good morning.
Welcome the Honorable Chief Guest, Professor Lalit Awasthi, Director, NIT Hamirpur and NIT Jalandhar. Our guest of honor, Professor R.K. Datta, our Dean Faculty Welfare, our HOD of the Department CSE, Dr. T.P. Sharma, Dr. Kamlesh Datta, convener of this course, and Dr. Pradeep Singh, coordinator of the course, and deans, heads, and faculty member and participants of the course. Very good morning to one and all. My name is Dr. Jyoti Srivastava, coordinator of the course from CSE department. I feel privileged to welcome our respected guest, professor, and delegates from the corporate and academia in this short-term course on machine learning or natural language processing. So I want to say here few words about our course. I want to introduce our course here. So this is the short-term course for machine learning for natural language processing. It is analyzing the text data is part of NLP. NLP is a field in AI which enables computers to understand human language or natural language. Natural language is actually difficult to handle, especially when we have sarcasm, slang, different dialects, and flexible rules. So in the field of NLP, deep learning techniques have taken a dominant role over traditional statistical methods. So researchers have been reporting much higher performance metrics analyzing these deep learning to solve problems like text classification, language modeling, machine translation, document summarization, question answering system. So this short-term course on machine learning for natural language processing provides essential knowledge and skills required to perform machine learning-based text processing in common tasks encountered in industries and research. So a combination of lectures and case studies will be there in the course, which will cover all the topics like machine learning, deep learning, NLP, and its application like machine translation, information retrieval, sentiment analysis, text summarization, and many other topics that we will cover during the course. Not only these topics will be covered, even we will also cover some of the aspects of speech processing and linguist knowledge. So when we talk about NLP, first we need to understand the language better, then only we can do some processing to extract the information from it. So to do justice with the course, we involve topics like linguist knowledge and NLP, machine learning, and deep learning. So as per these topics, we invited like experts from R&D like Walmart Lab, Accenture R&D Lab, and other reputed academic institutions like IIT Patna, IIT Delhi, and other NITs and other NLP experts who did very good work in the field of NLP. So I'm sure that all of you will find the discussion interesting and valuable. And I hope there will be a lot of interaction between the experts and the participants during the course. We look forward to a successful short-term course over the next 6 days. And I strongly encourage you all to become actively engaged in the various sessions of the course and discussions in MNLP 2020. So here I request Dr. T.P. Sharma, head of the department, to say a few words.
Thank you, Dr. Jyoti. First of all, the guest honor of the day, Professor Lalit Awasthi, Director, NIT Hamirpur. Sir, welcome you. First of all, this is a new era, new times, and a new beginning. And then I congratulate the coordinators of the course, Dr. Datta, who is the convener of the course, Dr. Pradeep Singh, Dr. Jyoti Srivastava, and I heartily welcome the presence of Dean Faculty Welfare, Professor Datta, Dean Academic, Professor Chandel, Madam Chandel, and other deans I cannot see on the screen, but all the deans, heads of the departments, and dear participants. So I welcome you all on behalf of the Department of Computer Science and Engineering to this very good program. And I must tell you that there are many other programs in schedule, and you can keep a tab on various on our website of the institute as well as of the department. So we are planning few more courses in the pipeline. Regarding the department, you might be knowing, most of you might be knowing, and many of you might be new participants in this particular course. Especially this department was established in the year 1989. And I'm happy to share that Professor Lalit Awasthi, who is currently the director of this institute, was the founding faculty member of this department. And who else could be better than a person now the director of the institute, his visions and his initiatives. Everyone understands and knows, and there is a new energy in the department with his presence as a director of the institute. And about this other things about this department, because we are having here BTech Computer Science and Engineering program. We are having a dual degree program, which is a 5-year program giving BTech as well as the MTech program. Then we have here various MTech programs like MTech Computer Science and Engineering, MTech Artificial Intelligence, and there are PhD programs going on, and PhD in various areas related to soft computing, mobile computing, AI, and many more areas are there. Okay, so without taking much time, because we are already late in schedule, so I thank you all for being a member or being a part of this particular program, and I hand over the proceedings to the coordinators, please.
Thank you very much, sir. Now it's my privilege to introduce you to our participants. Dr. R.K. Datta is a Dean of Faculty Welfare. He is affiliated to Department of Civil Engineering, NIT Hamirpur, where Dr. R.K. Datta is currently working as professor. He has authored and co-authored more than 250 national and international publications, and also working as a reviewer for reputed journals. Dr. R.K. Datta is having an active association with different societies, and around the world, Dr. R.K. Datta made his mark in scientific community with the contributions and widely recognition from honorable subjects and experts around the world. So Dr. R.K. Datta's major research interest involves geotechnical engineering. I request our Dean Faculty Welfare, Professor R.K. Datta, to say a few words here.
Chief guest of the inaugural ceremony, Professor Lalit Awasthi, deans, heads of department, faculty members, and dear participants. Now, on behalf of NIT Hamirpur, I welcome you all to this inaugural function of STC on machine learning for natural language processing. First of all, I would like to congratulate the Department of Computer Science and Engineering for taking up this assignment after a long span of Corona. This institution actually started long back in the year 1986 with 2 bachelor programs. At present, this institution is having 9 bachelor programs, 22 master programs, 2 dual degree programs, and almost PhD in each and every department. Now, this Department of Computer Science was actively engaged in organizing various events in the past, but for the last 2 years, there was some break because of some administrative reasons. Now, machine language for NLP application is the current need at present, because these techniques or algorithms, they are going to help to understand the meaning of the textual data, which is published in the newspaper, available in other media. Now, I have seen the brochure of the course. There I find some interesting topics: artificial intelligence, deep learning, machine translation, etc. But as far as my own interest is concerned, I am fascinated with the interesting application of the AI in today's world, because these days we know that there is a fight going on between Azerbaijan and Armenia, and lot many smart drones, they are attacking one party over the other party. Now these smart drones basically is a combination of computer vision technology together with the AI applications. So this is the most interesting thing which I have seen in these days. Though the more details about various aspects of machine learning shall be covered by the course coordinator during the next 5 days. And in the end, I just hope that the participants will really enjoy this course, and they will utilize these techniques for their research work. And at the end, I once again congratulate the organizing team for taking up this initiative and not taking much of your time. I thank you all for giving me this opportunity to be with you at this inaugural event. Thank you all.
Thank you very much, sir. Now I want to request to Dr. Kamlesh Datta, convener of the course, to welcome our chief guest, Professor Lalit Kumar Awasthi, Director, NIT Hamirpur.
Good morning, one and all. I hope I'm audible.
Yes, ma'am.
Yes. Good morning.
Good morning, sir. It's my honor as well as a privilege to welcome the chief guest of the function, Professor Lalit Kumar Awasthi, Director, NIT Hamirpur. Of course, today is a very special day because today sir has joined as formally is joined as a director of the NIT Hamirpur, and we have a very long association with sir, and it gives us immense pleasure to see you here as a head of the institution, and we are sure that we will be able to achieve much more heights in future under your supervision. I also welcome all the delegates, heads, deans, Dean Academic, Professor Rajivan Chandil, Professor R.K. Datta, Dean Faculty Welfare, heads of other departments, and participants from various institutions and organizations. We are sorry to really say that we are not able to accommodate everyone on this platform as we are all constrained with the technology. I would like to introduce the chief guest, who is our speaker for this inaugural session also. With great pleasure and honor, sir, with your permission, I would like to say a few words about you. Sir has done BE from Shivaji University with the first ranking in the university, MTech from IIT Delhi, PhD from IIT Roorkee. He is director at present NIT Hamirpur and director B.R. Ambedkar National Institute of Technology, Jalandhar. Since 1989, he is professor in CSE department, and during his stay of 25 years here, he was head of the department, head of a computer center, dean alumni, students and alumni associations. So he has a very illustrious repertoire of his activities and contribution to the institute. To name few, he is the one who established the computer science department, established computer center, started all the programs like PhD, MTech programs, and all this contribution earned him Best Faculty Award in Computer Science Engineering during 2005-2006 also. Regarding his administrative experience, he is a very popular and a very honored administration in education field. He has held several responsibilities as director cum principal under Government of Himachal Pradesh for JN Government Engineering College, Sundarnagar, Mandi, and Atal Bihari Vajpayee Government Institute of Engineering and Technology, Shimla. To say about Atal Bihari, this is the institution which he established on the pattern of Slide Longowal as founder director of the institute at that time. So he has got many first initiatives to his credits. He is guiding more than 12. He has guided more than 12 PhDs, and several are ongoing. and he has published more than 200 research papers in various journals of repute and conferences. At the same time, he is also reviewer of too many of the IEEE transactions, Springer journals, as well as elsewhere, and others also. He has 6 research projects completed. He is a fellow of Institute of Engineer, life member of ISTE, IEEE, senior member of IEEE, members of Internet Society, and the Society of Digital and Wireless Communication, and ACM. He is reviewer to many prestigious journals, editorial board member, PhD evaluations, and many other activities academic that he keeps on doing. He is a very widely respected speaker also for many of these events and other activities. Sir has visited several foreign universities for interaction and international collaboration in the area of academic and research, like Stanford University, USA, University of Urbana-Champaign, and California Riverside University, University Newcastle, and so on. He is bestowed with excellent organizational and management skills, leadership skills, motivational skills, which is very evident from his way of working in all these days that we have seen him. He is a dignified academic professor with the established in-depth knowledge in the discipline of computer science, education, and many other related fields also. Sir has pioneered and launched several FIRST initiatives, as you can see, and he always connect with the students in the benefit of faculty, institutions, and the students. Even the students always find him approachable, which makes him more popular and acceptable. And as we know, good leadership isn't something that just happens. It requires many competencies, and Sir is bestowed with all those competencies. Sir, we are grateful to have you as a director and also as a chief guest of this occasion. And we are very much thankful that you accepted our invitation at the last moment, because you always have a very tight schedule. But this is, I know it is close to your heart, and we are part of your system only. So we thank you once again, and I request you to address the gathering with your wise words. Thank you, sir.
Good morning. Thank you, Dr. Kamlesh Datta, for your nice words. And Professor R.K. Datta, Professor Rajivan Chandel, the coordinators for this course, Dr. Pradeep, and so many participants online connected, deans, heads, Dr. Teek Parwal, the head of department, and Dr. Srivastav, the coordinator. It's my privilege to be here on inaugural of this short-term course, and I definitely know that these such courses are of great help to those who wants to have research guidance in particular, because you have invited legacy of people in these topics, and this artificial intelligence and machine learning is a topic of today. Though I know when I was student, we are having research in NLP and research in artificial intelligence, but still it is only now, you can say, after in this 1 or 2 decades where it has progressed exponentially. And now everywhere, in every input, we find some stake of artificial intelligence, machine learning, and things like that. About the institute, Dr. Datta has already given a brief. This institute came in 1986 as Regional Engineering College, Hamirpur. Now it is rechristened as the Institute of National Importance. It's a deemed university. We take all academic and administrative decision, and the institute is quite vibrant. We have, as has been told earlier, the faculty members, they are all having excellent qualification, PhD from best institution in the country, and it is also reflected in the quality publication that NIT Hamirpur is doing. We have also started courses on artificial intelligence, and they have been introduced. One sincere advice to all faculty members is that we need to look into the syllabus and scheme curriculum which we are teaching to our students. Are the courses which we were taught essential for the faculty, for the student, for the staff, or we can change the curriculum and contents? That is one thing which I want to bring, and Dr. Rajivan Chandel need to take some lead in this by asking all the departments to have a revision of curriculum. Is sensor technology limited to electronics, or it is limited to computer science, or this need to be extended to maybe mechanical? This need to be extended to chemical, because every industry, now we talk of industry 4.0 and things like that, these are all possible because of the integration of sensors, the machine learning technologies, the artificial intelligence technologies, along with the industry, so that the efficiency of the system increase. So these, with this word, I stop here from general inaugural lecture, and as Dr. Kamlesh has told, so I would like to give a brief introduction about artificial intelligence and machine learning. I'll try to present if possible. ये कैंसिल करना नहीं, शेयर इसको. Are you able to see the presentation?
Sir, not yet.
Now, is it visible? Not?
Kamlesh madam, is it visible?
No, not yet.
Not yet.
Not.
Okay. So we have an expert with us. He will help us. So,
Sir, in the meanwhile, I would say that, yeah, okay,
Yeah,
it's visible. It's visible.
Anjali, you can say something, you can add something.
No, I just wanted to interact regarding the curriculum workshop. I think we can have a curriculum workshop in all the departments in maybe next month or something like that.
Yes, we must have, no?
Because that will take care of the NEP also, new policy, new education policy, whatever issues are there, those can also be taken up, and the curriculum can also be revised.
Yes, definitely.
Sure. Thank you.
Okay, dear. I'll just continue with this. So here is a small presentation on artificial intelligence and machine learning and overview. Am I audible?
Yes, sir. Yes, sir.
Yes, sir.
Okay, thank you. So this will be the agenda. We'll try to have what is intelligence and introduction to AI, introduction to machine learning, some research, recent developments in AI and machine learning, and what lies ahead, some drawbacks, and then I conclude this talk. So intelligence. What is intelligence? Basically, every one of you are aware of this fact. Intelligence has been defined in many ways. The capacity for logic, understanding, self-awareness, learning, emotional knowledge, reasoning, planning, creativity, critical thinking, and problem solving. More generally, it can be described as the ability to perceive or infer information and to retain it as knowledge to be applied towards adaptive behaviors within an environment or context. Intelligence is most often studied in humans, but has also been observed in both non-human animals and in plants. Intelligence in machines is called artificial intelligence, which is commonly implemented in computer systems using programs and sometimes specialized hardware. So, there are many questions to this slide itself. Whether intelligence is a relative term. So somebody can say yes, somebody may say no, but definitely intelligence is relative. Human intelligence. The human intelligence is the intellectual power of humans, which is marked by complex cognitive feats and high levels of motivation and self-awareness. Intelligence enables humans to remember descriptions of things and use those descriptions in future behaviors. It is a cognitive process. It gives humans the cognitive ability to learn from concepts, understand and reason, including the capacities to recognize patterns, innovate, plan, solve problems, and employ language to communicate. Intelligence enables humans to experience and think. Much of the above definition applies also to the intelligence of non-human animals. Now, as an engineer, all of you, I suppose most of you are engineers, if we can engineer the intelligence, if we can find out the essential constituents of the intelligence, or if we can define the intelligence behavior, if we can postulate this intelligent behavior, and then if we can write programs and give these programs to the computer, and if that computer starts behaving as if an intelligent machine, probably we can call it as artificial intelligence. I think you agree or disagree, but this is what I can perceive, that we can look into the intelligence, what are the various components of intelligence, and from these components we can try to postulate that these are the behaviors and how a person individual intelligence works, and looking at that we can try to mimic the behavior of a human being into a machine. So what is artificial intelligence? Something artificial plus intelligence. So we can say machine, and then you get a artificial intelligence. The artificial intelligence is intelligence exhibited by machines rather than humans or other animal. The field of AI research defines itself as the study of intelligent agents, any device that perceives its environment and takes actions that maximize its chance of success at some goal. The science and engineering of making intelligent machines, especially intelligent computer programs, is artificial intelligence. AI is using computers to solve problems or make automated decisions for tasks when done by humans typically require intelligence. History of AI. In 1950, Alan Turing wrote a paper titled Computing Machinery and Intelligence that coined the question of, can machines think? But only in 1956, John McCarthy coined the phrase artificial intelligence. Using trial and error method, reasoning was developed as an ability for machine. Then came into the picture the imitation game. The AI is been evolving until now. The recent evolution in 2016 was AlphaGo, where a human champion in Go was defeated by a robot. Application areas of AI. There are many areas, I think everywhere. I see that in next decade, you'll find every area has application for artificial intelligence, banking to organize operations, investment in stocks and manage properties, augmented reality, robotics, image speech recognition, fraud detection, emotional recognition, security, authentication. The augmented reality and robotics, you can find the application for this is immense. You can find in every area you can have a augmented reality or robotic. AI in perspective, AI have created 2.3 million new jobs while eliminating only 1.8 million jobs in 2020, a study by Gardner. So you can see the impact of AI automation on jobs, and you can see the revenue from AI market. AI itself has the potential to contribute up to $15.7 trillion to the global economy in 2030. It is an estimate which is more than the current output of China and India put together. 45% of total economic gains by 2030 will come from application of AI in product enhancements and stimulating consumer demand. So you can see the graphs, how the AI revenue market is increasing every year or every 5 to 6 years. You can say the similarly the job openings in AI skill wise, you can have jobs related to machine learning, job related to deep learning, job related to natural language processing, computer vision, speech recognition. All these areas are having input from AI. Startup developing AI systems, so they are increasing, and we can have exponential growth in 2015 onwards. AI assistants in various sectors by year 25. Say tutor, travel agent, text prepare, office assistant. Everywhere you will find application of AI. Annually published papers in AI, they are also increasing exponentially. Classifications of AI, you can have different classifications. One is a simple classification is strong AI. The computers thinking at level that meets or surpasses humans. Computers engaged in abstract reasoning and thinking. This is not what we have today. There is no evidence that we are close to strong AI. Weak AI, the computers solve problems by detecting useful patterns, also known as pattern-based AI, used to automate many processes nowadays, self-driven cars, language translations, voice assistants. This is the dominant mode of AI today. Categories of AI, the reactive machines. Reactive machines use past experience to determine future actions. They don't refer to past experiences and cannot improve with practice. Reactive machines simply perceive the world and react to it. They have no memory and cannot use past experiences to inform future ones. Limited memory. These machines retain data for a short period of time and use data for a specific period of time. They cannot add it to a library of their experiences. Their decision-making functions are generally used in autonomous vehicles. Theory of mind. The theory of mind is all about imitating the mental models, that is the human brain. It forms representations about the world, starting from thoughts, emotions, memories. This kind of artificial intelligence is the future and doesn't exist as of now. Self-awareness in machine is when they understand the current state and can use the information to infer what others are feeling. This type of AI does not yet exist, but will be there in the near future. Definitely these last two types are being there in the laboratories. Major AI approaches, we have two different approaches at the base, logic and rule-based. In this, they represent the processes or systems using rules. Example is TurboTax Expert System, a software for computing tax liabilities. On the other side, we have machine learning based, pattern based. The algorithms find patterns in the data and infer rules of their own. These patterns can be used for automation or prediction. Machine learning is the dominant mode of AI nowadays. AI versus machine learning. Artificial intelligence is a technique of incorporating human intelligence of machine. It is the superset of machine learning and deep learning. Machine learning is a subset of AI that comprises of algorithms and statistical methods used by machines to perform a specific task and improve with experience while learning on its own. Deep learning, it is the subfield of machine learning that uses artificial neural network for computation for giving accurate results. Come to machine learning. Machine learning is the subset of AI where machine learning algorithms are designed in such a way that the machine tries to learn by itself without being explicitly programmed on each and every instruction. So there is a machine and there is a dog in this picture. Different pictures of the dog can be trained or can be given to the machine. Then we can ask, so as it will be exposed to more and more data, it tries to internally modify itself and adjust according to the data to which it is exposed so that it will not rely on human experts to program them. So where is dog in the picture? So there is a picture to the right side where the machine can be asked, can it identify where is the dog? Types of machine learning, we can have supervised learning, we can have unsupervised learning, we can have reinforced learning, the supervised, the task-driven, unsupervised, the data-driven, and reinforced, they learn from mistakes. Supervised learning, in supervised learning, the machine is provided with the level data set. It already has input and output parameters. So when the machine is given a new data set, the supervised learning algorithm examines the data and produces the correct output according to the level data. Use case, detecting cancer patients. There would be some parameters and symptoms given for detecting cancer patients. It can be pictorial views, it can be the symptoms, and many more things which are input. The machine will try to classify the patients according to the symptoms to determine whether they are having cancer or not. So supervised learning is best for classification and regression problems. Unsupervised learning, in unsupervised learning, the machine would not have any level data set. The algorithm is designed in a way that it tries to learn by itself without any supervision of data. This involves clustering of data. The use case can be Netflix recommendation system. It works on the same technique as it saves for the user's watched history and recommends a similar content to the user. So you can see many times the recommendation system, basically not only Netflix, at times you might be going to some smart store. Depending upon your choices, depending upon your data, what you have been purchasing, there can be the information which we can ask for. I'm sorry for an interruption. I have an important call for a couple of minutes. 1 minute, I'll be there. Sorry for the interruption. So the recommendation system which we have, they usually work on this kind of past data. The reinforcement learning, in reinforcement learning, the algorithms are designed in such a way that the machine tries to find an optimal solution. It adopts the principle of reward and punishment, and by this approach, it moves to the correct result. Steps machine, the main points are learning, and then pattern detection, and then data, and then self-programming. The example can be email spam filter. If you want to distinguish between the emails, whether it is a spam or it is a wanted email, the system detects patterns in email about likely markers of spam. Then the detected pattern, the emails with the earn cash, more likely to be spam email. So this kind of programming we can do, that if there is a content or subject or some headline with earn cash, this is likely to be a candidate for spam mail. Can use such detected patterns to make automated decisions about future emails. Earn cash detected in 10% of spam emails, so 0% of wanted emails. So you can say that the earn cash can be any pattern which we find in the emails that can put that this mail can be now put in as a spam. Similarly, you can have to improve the identification can be improved. That probability of spam can be put up, that if something, some email contains free, then it may be that 70% of such emails are spam. Similarly, maybe 90% of the spam containing the word earn cash are spam. Or from Belarus, 85% of the emails are having spam. So the identification improves, algorithm improves in performance in auto-identifying spam, as it is able to examine more data and find additional indications of spam. Algorithm is learning over time from additional examples or inputs. Recent advancements in AI in healthcare, the diagnostic medicine, AI can be used to predict and diagnose illegal illness at a much faster rate than medical professionals, while reducing the rate of misdiagnosis. AI-based symptom checkers can be used to listen to the patient's symptoms and health issues and use advanced data to reach likely illness and guide the patient to the right care. You can find out that in human beings, it's very easy that there are so many symptoms which apparently are diagnosed on one-to-one basis can lead to a wrong diagnosis. Like if there is some irritation in eyes, if there is some irritation in ears, this may or may not be limited to eyes and ears only. There can be some symptoms related to sinus problem or any other problem, a bigger problem. So it's very good that AI-based system, they can learn, they can look into, they can ask the question, they can make you spell out what all different things has happened to a particular patient, and then you can always they can always give a proper recommendation. Robotics and patient monitoring, virtual assistance for nurses, assisted tele operations, assistance for administrative workflow, fraud detection, doses error reduction. There are many areas where AI can be used in healthcare. Automation, you can have a expert system replacing a doctor, though it is not recommended, but all the expertise in a particular area can be put into a computer system. Similarly, AI in education, So differentiated and individualized learning can be look into the individual persons, can be look into the photographs and then find out the individual people doing the job. So customized curriculum, intelligent instruction design, presentation translator, automation basis activities in education like grading, virtual tutors, virtual facilitators and learning environment, intelligent tutoring system. Can there be a tutor who can have all the knowledge in the world and he can be a better teacher than a human being? Can this happen? These are the questions. Then we can have AI in banking. So digital first banks are sometimes dubbed the challenger banks or neo banks. Investment banking, simulation, fraud protection and middle office, identity verification system, lending and risk management. There's so many areas where you can find out where we can use artificial intelligence. Then AI in business, adaptive intelligence, chatbots, automation, analytics, CRM, the customer relationship management platform, and now you can put up many list is long. You can have the recommending system. So the advertisement, how the recommended advertisement system work. Everyone nowadays is connected with the mobile phone. So if you are connected with your email accounts, and if you search for a ticket to maybe Tokyo, then your email box will be having many offers to fly to Japan. These are recommendation systems. Similarly, purchasing in a store, intelligent store, as I have told you earlier. So these recommended systems, they work on these statistics and intelligence. Autonomous driving. This is future car. We are showing that driving the car to the gas station or recharge station when it is running low on fuel, adjust the trip's direction based on known traffic conditions to find the quickest route. These things are happening, but not with the vehicle, with your chatbots, with your personal assistants. They are able to find out that if you are daily going to a route and you are taking your devices with you, they can always recommend that today there is a congestion. Incorporate speech recognition for advanced communication with passengers, natural language interfaces, and virtual assistant technologies. What are the some of the drawbacks of AI? The limited ability. The machine will know only what you will tell it. Okay, so slow real-time response, cannot handle the emergency situation, difficult coding, though many persons, many industries are coming forward, and high cost. So far it is a costly affair to have AI assistance for anything. So thank you. With these words, this was a small presentation. I thought I'll be able to give you some inputs into artificial intelligence and machine learning. Thank you. Jai Hind, Jai Bharat.
Thank you, sir. Thank you for an interesting introduction and a detailed right from the start, how it started and what we have what we are thinking now and what we want to achieve. We have covered almost every aspect of AI that people are actually dealing with. And this is, as we have also discussed, that the current scenario, all the technologies that we need to have to excel in our life, like machine learning, deep learning, NLP. I think you have touched almost every aspect of AI, and this will surely be a good start for all our participants. They will, at least I know that there are many people who are not at all from the background of AI also, and it will be very much a good start for them to know that how it really began. And it's not really new thing, but nowadays we are seeing a boom in the field of AI. So with this, I thank Professor Lalit Awasthi sir for supporting us and encouraging the faculty of CST department NIT Hamirpur for taking up this initiative. I know this is very close to your heart, and this reminded me also of our first short-term course, or you can say FTP, which we conducted together long back on AI and expert system. So, sir, thank you very much. You have been always a big support to us in all the activities that we undertake. Thank you, participants, also for joining us, and many of the participants who have not been able to join in the group here. As you know that there is a constraint of the technology. We cannot accommodate more than 100 here. So therefore, we are also streaming it on YouTube. This was suggested by our director sir only, that we should not restrict the participation, and you please explore these other avenues also. So naturally, this is a limitation. Next session that we'll have will start at 2 o'clock, and we'll meet at 2 o'clock. Thanks. I would like to thank Dean Faculty Welfare also, who has been kind enough to give us the approvals and support required regarding these course organizations. I would like to thank Dr. T.P. Sharma, head of the department, for extending all the support from the department also in this regard. The technical staff of Computer Center, especially Dr. Siddharth Chauhan, Dr. Anil Chauhan, and Ashwini Sharma, Jagdish Kumar, and all his team, they have been really helpful in making this event possible. So, and the participant, of course, I know that we are not able to accommodate most of them, and we will be meeting at 2 o'clock now. Okay, and we'll figure out that what can be done if some regarding your attendance, as I'm getting the messages that attendance has to be also taken care of. So we'll take care of that aspect also. And thanks one and all. So if anyone has any question, they can also ask.
Yes, there is one of our students, Triveni Pal, has joined. I can see him.
Yeah, Triveni, do you have any question? Mic on karo beta. Mic aapka off hai. So some questions I'm seeing.
No, thanks, ma'am. I don't have any question. Good morning, sir. Good morning. Good morning to you, sir.
Good morning and God bless all.
Okay, so I think there is one question from Mr. Hasmat Malik. How can we decide that AI should be used or data analytics? I think he is actually differentiating between AI and data analytics. Sir, please.
In data analytics, what we work is on the analysis of data, and then it is kind of what the result of the data analytics are similar to that of a artificial intelligence system, because it gives input to a recommending system. Basically, all the recommending systems which we have, they do some kind of data analytics, isn't it? And Dr. Kamlesh can add to this, the artificial intelligence and data analytics systems.
Yeah. So, see, AI is a broader umbrella under which you'll find that there are several domains are defined, and data analytics is one of them. So you'll find that there is a data analytics concept, then there is a text analytics also. So if you are differentiating again between these two, data will be you are dealing with the numerical data, whereas in case of a text analytics, you are actually handling the text analytics. AI actually has got other domains also. You can say that NLP is an area, then you have got computer vision. So data analytics is just one part of your AI. There is another question you have, Pritam Paul has asked, that is complex cognitive feats in human intelligence. So we'll be having one of the presentation in our sessions, okay, forthcoming sessions. So there I think we will handle all this detailed kind of a thing, because this was an introductory talk. Anything detailed will be taken up in the next lectures by the experts who are working in this area. Okay, so we have another question.
I'll add to this. Kamlesh, I'll add to this.
Yes, sure.
Data analysis refers to reviewing data from past events for patterns.
Yeah.
And predictive analytics is making assumptions and testing based on past data to predict future. So there is data analytics, there is predictive analytics. And then AI machine learning analyzes the data, makes assumptions, learns and provides predictions at a scale and depth of detail impossible for individual human analytics. So it is all combination of predictive analysis, data analytics and AI algorithms that will help in giving you the correct on the fly kind of recommending systems.
So hope this has answered.
Okay.
I think one more question I find that, but this relate to I think more of about the administration things. Does NIT Hamirpur provide PhD research visiting in CSE for foreign scholars? Sir, I think you can answer better about this thing, or I think Dean Academic we don't have here, but I think Sir can answer this question. Are we going to introduce?
What is the question?
Are we going to have a PhD research visiting at NIT Hamirpur?
Visiting PhD research.
Yeah. So this I think we can take care only through the Senate, if it is possible, because in new national education policy, I think we can look.
Sir, with your permission, sir, with your permission, can I?
Sure, you add. So we have Dr. Okay, Dean Academic is also in the meet. We have all the right persons in the meet with respect to this question.
So, with your permission, sir, can I talk about this? For foreign students at UC and for foreign students at UC and PG, we can say provisions like DASA, then ICCR. Then there is a program which has been launched recently called Study in India program, which caters the requirement of UG, PG as well as PhD. But conditions are quite stringent. So maybe in the near future, NIT Hamirpur will be participating in this scheme, and that way it will give opportunity to foreign students to enroll for at PhD level also under Study in India program.
Also, we can have a short-term visit to the institute. If somebody is interested, they can come and stay at the campus, because we are not restricted on that. Only thing is that the visitor, they need to find out some ways and means of getting the financial assistance to be here on the campus. So NIT Hamirpur is open to invite people from other countries. They can come and be part of the system for small chunks of their time. They can come and they can spend time. We definitely have very good facilities for research pursuits in technology, science, and management.
So I hope we have answered the question regarding this. Dean Academic also may add to it. Professor Rajivan Chandel. She is not here. Okay, so I think this is answered. And there are a few more questions, like I think more about the undergraduate courses, to include ML deep learning in the undergraduate courses or as an open. Then there is, I think, I think we can take away, because sir, you started with your talk initially, your address, that we should have a revision of a curriculum. and you have already insisted that we should be including these kind of our currently relevant topics and offer it to other branches also. Across the branches it should be offered. So maybe when we'll have the revision of curriculum workshops, they can be undertaken at that point of a time. Okay, Dean Academic, I think can speak also. She can add. Mic is not working. Okay. So I think there are the questions, most of the questions that I find technically, they will be, I think, will take up at that point of a time, because they will require mathematical details discussions. As I understand, Mr. Umesh Sehgal, then what we have, Mr. Pritam Paul. Okay. So there are all questions which will be taken up at that point of a time. Okay, so I think this workshop at least has initiated the thought that we should go for a initial of this starting of the curriculum revision at our institute itself, induction of foreign visitors, scholars, or all these ideas will be taken care of. So with this, I think Dr. Pradeep Singh.
Thank you, ma'am. Thank you.
Thank you. So I think we can close and we'll meet at 2 o'clock.
Yeah.
Okay. So thanks one and all. And we will be meeting at 2 o'clock. There will be some slightly modification in the schedule. We'll talk at that point of a time. We'll be talking about TensorFlow, PyTorch also, of course. So thank you, thanks one and all. I would like to thank my coordinator, my team, who has been working all through this period. Though during Corona it was difficult, but they shared all the things that I have been saying to them. Okay, but still they took the hearts and went ahead with this launching of this program. Thank you very much, and take care.
Thank you.
Today we have a match of global interest for you. It's Barcelona against Real Madrid, and I'm Martin Tyler. Alan Smith is with me. And what hasn't been said, that's been said a million times about this game. It's thrilling, Alan. It is. You look at those two teams down there, the superstars, the sheer depth of talent in both, and it rarely disappoints, does it?
Usman? Usman, please keep your mic off. Hello? Hello? हाँ मैम
So, hello, Dr. Jyoti.
Hello.
Hello. So I think we can start.
Okay, ma'am. Okay, so good afternoon, everyone. I would like to introduce here Dr. Kamlesh Datta, who will give expert talk on latest machine learning trend in NLP in the next session. So Dr. Kamlesh Datta, she is associate professor at NIT Hamirpur. She did her PhD from Guru Gobind Singh Indraprasth University, Delhi, MTech from IIT Delhi, and MS with honors from Vladimir State Technical University, Russia. She has supervised 7 PhD theses, 25 plus MTech dissertations, and published more than 160 papers in international journals and conference proceedings. Her area of research includes natural language processing, anaphora resolution, discourse analysis, information security, software engineering, and e-learning. She has received 3 Best Paper Awards for her research publication. She is recipient of Outstanding Award from Cisco Networking Academy. She is holding 2 copyrights of India, namely Bhukamp Rodhi E-Chakri and Retrofitting E-Chakri. So it's our privilege to have a lecture on NLP from such an expert. So now I would like to request Dr. Kamlesh Datta to please deliver her session now.
Thank you, Dr. Jyoti. Good afternoon, one and all. And I think there is a slight, people are having the schedule, there is a slight modification. So the next speaker will be following after this talk. And the topic of my talk is latest machine learning trends in natural language processing. So broadly, the outline of my talk will be around what the NLP is, what AI is, what are various NLP tasks that are to be accomplished actually that we are required to perform, and then what machine learning trends are available and which are primarily suitable for NLP tasks. And of course, the current trends that we know is about the deep learning application to NLP. So we'll see what deep learning mechanisms are suitable for NLP task itself and what tools are available. Also, at the same time, we also know that any technology that we are using has got its limitations also. So we'll go through these limitations also. And starting with NLP, as we know that NLP, natural language processing, is considered to be an AI problem. So what the AI problems are, they are those problems which we consider that we are not able to solve them directly and that no direct solutions are available. So we apply some AI techniques which we may have studied, those who have studied the AI course, that we apply certain AI techniques ranging from the search method or search techniques, or we are employing some optimization techniques or machine learning approaches. So we see that how these AI approaches or methodologies can be applied to this particular task, that is natural language processing. So this is a branch which allows computers to read, interpret, and understand human language. So specifically deals with the human language, and we know that human language can be in different forms. It is a text, it can be audio also. So that means speech processing is another domain that we are interested in. But then there is more about the signal processing and all. So here nowadays that goal of NLP is that machine should carry out our repetitive task, high voluminous task, which otherwise any human being will find it difficult to perform. Now, considering the NLP, natural language processing, which is to be carried out, that means we want our text, the languages to be converted, or languages are to be dealt with by the machines. So there are different stages that we need to go through. One is the lexical analysis, that is the first stage where we deal with the structure of the word itself. And at this stage, we normally do the collection of the words or phrases and their lexicon of the particular language. Then comes your syntactic analysis, which is parsing. That means you have arranged the words. There is a collection of words, but you can't deal with the collection of words as it is. So some rules are required, and generally we call them as a grammar. So based on the grammar of that particular language, we perform the syntactic analysis. Now, any word that you have taken, it has got a meaning, and even these meanings, interpretations, they're maintained in some kind of a dictionary, and it has to mean mapping syntactic structure on object has to be performed. So for a particular domain, you have to see what semantic is to be followed, so this is another level that has to be achieved. Above that, next level of analysis that we have to deal with is a discourse integration. That means the meaning of any sentence will depend on the meaning of some previous sentences. So here, the overall interpretation has to be taken into the context only. And then finally, the pragmatic analysis, that what interpretation actually means. So even when we are writing sentences, we are speaking out, they may give certain kind of interpretation in the real world. So these are the stages which any NLP task that you deal with have to perform. We know that NLP has become now an important domain in AI, and which has been embraced by most of the organizations, being the commercial or even government organizations. This has become one of the top priority area for all the organizations. Why it is being employed in most of the applications? That large-scale analysis is required because of the boom in the internet technologies. We find that a lot of text data is created almost every day, and some meaning has to be extra, so that has to put into use. So large-scale analysis is possible only if we are NLP techniques. What is essential? What we need to understand about the particular text based on the particular problem. Then we also can perform the automatic processes in real time. So we have got machine learning tool with the natural language processing. They can understand and analyze the information very effectively around the clock. So whatever data is available, that can be easily processed by the machines with the availability of machine learning tools and technologies. And further, since it is being done by the machine learning approaches, they are not subjective like human, and they do not change with the time that, okay, this time now and another time some another results would be there. So no subjectivity is there. So it gives a consistent and unbiased criteria. So this is another advantage that we are employing NLP in most of our commercial and even the governance applications. We keep on talking about AI also all the time. So the relationship with the NLP and AI, we see that NLP has evolved from the rule-based to the machine learning infused approaches, and it overlaps with the AI. So many a times there is a confusion, and interchangeably the terms are being utilized. And in NLP, there are two broadly subsets. One is the understanding, natural language understanding, where machine has to read and comprehend the text, whereas generation is related to the transformation of the data into human words. For example, you have got images or pictures, and they have to be captioned. So there story generation, story creation, and etc. So there, in many of the application language, and we are actually performing the task of natural language generation based on the data available to us, and we are generating the text. Whereas in case of understanding, there is a text, it has to be understood properly by the machine. Some of the terms which we keep on using here, and broadly also we are using. So artificial intelligence, we call it as a broad discipline of creating intelligent machines. So it includes your robotics, your computer visions, psychometric data and all. So all the various domains are there, various application domains are there, which actually requires AI which are covered under the umbrella of AI. So it is a broad discipline of creating intelligent machines. Whereas machine learning, it is related to the system that can learn from experience. So in machine learning, a data is given to it, and from that data, it tries to understand or infer or conclude some kind of decisions. Another term that we will use here is a deep learning. Now here, the difference between machine learning and deep learning is this just simple meaning which difference we are considering, that machine learning normally has been employed on a limited set of data, whereas in case of a deep learning, it actually works on the large data sets. So you will find that it is the deep learning has actually evolved from the machine learning only. And there are other differences also. We'll talk about them also. Another term which will be important for us is a neural network. So it is a model of human neural networks that are designed to help computers learn. Now, deep learning actually has evolved from the neural network model. So various neural models are actually have been evolved to handle large data sets, and thus we talk about the deep learning. And natural language processing is about the systems that can understand the language. In real life, as we keep on saying, why NLP is very important nowadays, you see the range of applications, and you find that the wide variety of applications are there. For example, information retrieval. Your Google is using information retrieval, information extraction, Gmail structure events from the emails, machine translation. We are using machine translation in our application, and text simplification. That means rewordify or simplify the meaning of sentences. So if you remember, if you are aware of the speeches of Dr. Shashi Tharoor, okay, so the kind of language being used, you can understand that they need to be simplified. Otherwise, for normal people, for a layman, at times it becomes very difficult to understand. So text simplification is another area which again relate with the NLP. Sentiment analysis. So different kind of news are being created and floated on the net. So you can see that one has to figure out that what kind of a news, what kind of sentiments are there within this news. So this is again an important area of application. Text summarization, then spam filter, auto predict, auto correct, speech recognition, question answering, natural language generation. So all the movies which are created, they have to be captioned. So the captioning of a video data by using the text is another real application, real life application of NLP. Any organization, be it the government organization or other corporate organization, they are also benefited from the NLP, because there also a lot of documents are created almost every day, and they have to be handled and managed and analyzed from different perspectives. So they can analyze the feedback of the public, and they can improve the prediction, they can improve the regulatory compliance, and consequently they can enhance the policy analysis also. So this is important for the government organization, important for the corporate world, and even for in general purpose also. Where the data is coming for this NLP, as on today, if you see, there are a lot of sources are there. Your whole social media is full of text data, your online reviews, survey responses, various organizational policies, documents, financial, medical. So all the document nowadays is being digitized. So they are all actually a big source of the data as a data for our NLP applications. If you talk about 80s or 90s, such data availability was difficult, but now we find that this is booming like anything. So machine learning related with the natural language processing, we want to relate with it. So we say that it is application of machine learning for natural language processing involves using machine learning algorithm and narrow artificial intelligence to understand the meaning of a text documents. So we apply machine learning algorithms to the natural language processing task, okay, to understand the meaning of the text documents. So by the application of machine learning and AI, what we are able to get, we are able to improve, accelerate, and automate whole of the process. And we are able to understand, apply the text analytic functions and identify NLP features also. We are able to convert the unstructured text into some usable data, and some kind of an insight is available there. So machine learning for NLP actually is an activity where we want to create a learning framework and provide properly formatted, relevant, clean data for machine to learn from. So first of all, it has to be provided with the correctly formatted, clean data. Then only the machine learning algorithms will work on it. So it means that we have to create first of all, input has to be there. Secondly, a model, that is a mathematical model, has to be created, and a machine learning model finally is the culmination of the learning that has been acquired from the trained data. So we have got a data, we create that data. So in order to use that data, first of all, it has to be pre-processed. And once you have created the models, you can actually evolve the model also, and more learning can be acquired. As more learning is acquired, you can also modify this model. So one model has been created, if it is okay, you can further work upon it and create new models also. The advantage of machine learning here is that normally, traditionally, the thing that we have been doing is the algorithmic approaches. So use of the rule-based models or algorithmic approaches, okay, there it had the limitation that it could work, it could not be generalized. So machine learning allow you to handle the novel cases as well as allow you to generalize also. So how it does that, if a case resembles something the model has seen before, it can be used this prior learning to evaluate the case also. So overall is that we are trying to create a system, model continuously improve, and the task that we have already earlier carried out. What we do in the machine learning with respect to the NLP actually, we actually apply here statistical techniques. And statistical techniques are applied for various NLP tasks like part of speech, entity recognition, okay, sentiment analysis, and various other tasks which are there related to NLP. So it is the application of statistical techniques to NLP. And these techniques, the techniques which we are using, they can be expressed as a model and can be applied to other texts also. So if we work in this order, that we techniques which have created a model, we have created a model, then we are applying it to other texts, then it is a supervised machine learning. On the other hand, we can also go for an unsupervised learning approach where there could be a set of algorithms that work across large set of data to extract meaning. So two modes are applied here, or others are also there, but supervised and unsupervised machine learning approaches can be applied to it. Why we are talking about the text data and machine learning? Reason being that for NLP, text is a data. And the characteristics of a text data is that, first of all, this is very huge. The collection of the text data we see, it has got hundreds of thousands of dimensions. But at the same time, if we create a matrix, it becomes a very sparse. So whole space becomes very difficult to handle at times because there is a sparsity of the data representation. And naturally, we have to work on that particular high dimensionality things only. There is a sparsity in the data set. Whereas on the other hand, if you deal with the image data or video data, they are very high dimensional data. Okay, their contents are very high, but in text data, available the dimension is very high, but the usage is very less. There are several approaches which can be used. Since we have said that it basically relies on the statistical models, okay, and we train these models on some input data, we get some output data, and this output can be used to produce some kind of predictions. So instead of when a normal tradition is that we assign certain rules, we make use of certain rules, and by using those rules, we actually carry out the NLP task. But if it is machine learning, we'll be using some general available techniques, the one which we have mentioned here, maximum entropy Markov model, robust risk minimization model. We can use learning as a search optimization, support vector machine, conditional random field. So various NLP tasks can be actually performed by using any of these rules also. So these are the most commonly used machine learning model for our NLP tasks. Coming to our supervised machine learning for natural language processing, how do we go about it? That we take a text, and that text has to be actually tagged or annotated with examples. So prior tagging has to be there, and based on the prior tagging, we actually train the statistical model. And once it has been tagged, okay, then we can give untagged text can also be analyzed by using this trained statistical model. Further, when you get in better data sets, larger data sets, you can further retrain the model, and it can learn more about the documents it analyzes. So you can work with a small set of data sets, and then it can be applied on the larger data sets also. So, for example, we can use the supervised learning to train a model to analyze movie reviews. And once we have trained it on the movie reviews, we can further train it to factor it in the reviewer star rating also. So that means further you can refine your models also. What is the advantage of this approach? That we can test different algorithms and features because it is a data-driven approach. It is feasible to improve statistical-based system by including new data to data sets, which can be used for training purposes. Another advantage that it has is that it can be easily adapted for other languages. And by learning and combining various features, statistical-based approaches can scale a high degree of performances. So most commonly used NLP machine learning algorithms are support vector machine, Bayesian network, maximum entropy, conditional random field, and nowadays the trend is to use the deep learning models. So let's see some of the tasks. One is that we have to perform in NLP is a tokenization. So in tokenization, what we do, we split the phrases, sentences, paragraphs into a smaller unit, which is known as a token. And these tokens are normally the individual words or the terms. So you can do many things in the tokenization. It can be only the word tokenization. We can predicting the part of speech also for each token can be performed. Okay, text lemmatization, removing stop, but these are the activities which are being required to perform during the tokenization. Now in the Python platform, if you are using, you can find different resources for performing the tokenization task itself. So I think there will be a session, a hands-on session. I think there was a question in the morning. Will we be having hands-on session? Yes, we have scheduled one hands-on session also. So you can use for tokenization in the Python because Python is the most commonly used language platform also, and most of the platform have been developed by using Python. So you can use NLTK, you can use PESI, you can use Keras, you can use GenSim also. Next task that we have to perform is a part of speech tagging. So identifying each token's part of speech and then tagging it as such, like a noun, words, etc., is the activity of the part of speech tagging. Why we are doing? Because the words which we are dealing with, in the NLP, they can have different kind of a root form and they can have a different kind of a tagging. For example, if we are using living, if it is a verb, whether it's a verb or it is an adjective or it can be a noun also. So naturally here it can adopt any form, but it will depend on the part of speech tagging which is assigned to the particular word at that particular point of a time. So we need to correctly identify part of speech in order to recognize entities, extract themes and process the sentiments. Part of speech tagging again is a supervised learning approach because you already have a part of speech tag corpuses. For example, these are the standard corpuses available. So they are the two tag sets which are universally available. One is universally dependency tag set and used by SPECI, and another one is the pen tree bank tag set, and it is used by NLTK. Now, how well it has been tagged will actually determine also the performance of your NLP task. So in general, if you see this part of change is a very old assignments. So this has been done initially by using manual tagging only. Thereafter, rule-based tagging has been introduced. So for that, Brill tagger you can use. Another model that is being used is a stochastic and probabilistic model, where you can use CRF, naive-based or hidden Markov models also can be utilized. And current trend is in order to have the tagging, you can use the deep learning methods, which we'll be talking. So that means from the rule-based, we have moved on to the machine learning and next to the deep learning parts. So to a certain extent, part of speech tagging is considered to be a solved problem. That means it has reached its perfect level. That means the records or the data sets which are available, they have been well tagged from the perspective of a part of speech tagging. If you want to carry out the part of speech tagging using the machine learning algorithms, you need to actually have the corpus. So you can use the corpus which is available from the NLTK as a entry bank, or you can use the Universal Dependency Corpus, which has got the formatting. So you can extract the features, and then you can load and train a machine learning algorithm, and then test the trained model also. So if it is with the data, if it is you are giving the one score acceptable, you can save that model, and then you can use that model in your algorithm of your application. Another task that is important from the NLP perspective is named entity recognition. And entity is extracting identification. So we are extracting a key information of the entity from the text. It can be any word or a series of words. So named entity recognition can be simply single word, or it can be a series word. But then even the series of words, they can infer something differently also. For example, when we are using named entity recognition, machine learning models, then it may find a word like super.ai in the text and may classify it as some company. And in the text that we deal with, what we know that there is a large variety of things that we are dealing with nowadays, like a hashtag, emails, mailing address, etc. So we have to now even handle all these kind of entities as well. So this is named entity recognition as such will naturally depend on the accuracy that we have achieved in the part of speech tagging from those models. Next task of the NLP that one would be interested in is a sentiment analysis, where whatever piece of writing you are dealing with, you are actually assigning some kind of a polarity. Okay, so weights are assigned with the sentiments, theme, topic, okay, or a particular segment of the text also. So it can also be evaluated as assessed for its polarity or sentiment values. For example, we have taken the phrase "sick burn." From the perspective of video games, it can be a positive statement, whereas if we consider about the medical related issues, then it may not be it will be considered as a negative. So that means same things which we contextually, that means generalization is very, very difficult in such cases also when we are handling the sentiment analysis problems. Now, creating a set of NLP rules to account for every possible sentiment score for every possible word is also very, very difficult. This is one thing that is difficult, that we cannot have a generalized way of specifying the sentiment with respect. Okay. So each language also requires its own sentiment classification model. That means sentiment analysis is a difficult thing. And naturally, even from language to language also it varies. Another task in NLP that we carry out is categorization or classifications. So we train the text classification models, we use the pre-sorted contents, okay, and then we find out if we have reached the desired level of accuracy. So this is another activity we perform with respect to our NLP related things. Another model that we use for NLP are the unsupervised machine learning NLP. And here the clustering means that we are actually documenting the groups into the sets, okay, and they can be sorted based on the importance or relevancy. For example, if we have got a classified document, so then we want to put them into different categories, that how most carefully something has to be something which cannot be shared, or something which can be shared after a certain amount of a time, or some documents can be shared with a certain kind of a group also. So clustering is very much useful in the NLP task. Here we can use the latent semantic indexing technique, which identifies the words and phrases which occur frequently with each other. So this is a technique which can be utilized. Another technique that can be utilized is the matrix factorization. For example, here we have used the example of a sentence, I threw the ball over the mountain. Now, threw, it has to be associated with something. Either one is a ball, another is a mountain. So what we know that ball has to be associated more closely. Threw has to be more likely to be associated with the ball than with the mountain. So this says that we are able to do the clustering where even we are not really able to find the similarities. So in a broader perspective, we see that overall understanding in NLP actually requires a lot of things. You have to understand the semantics. You have to understand the syntax. You have to understand the context also. So this way it results in a lot of processing activities that one has to perform even to understand a single sentence also. So full understanding requires a successful combination of all three components. Just knowing syntax is not sufficient. Just knowing semantics is also not sufficient. We have to combine all the three approaches. So this is to many of the organizations commercially who are actually handling the NLP tasks, okay, they go for for example, the Lex Analytics, okay, you can see that here they are combining they are following the hybrid approach. So they are combining many things here. And so if you see at the lowest level, if you see it is maintaining a syntax matrix, it is also maintaining a concept matrix information. That means semantic information is also there. Next, if you see it is doing part tokenization, part of speech tagging, chunking, sentence boundaries, everything is there. And then comes your next level comes your named entity, themes and topics. Okay. And it is also applying machine learning as well as the rules. So it is not saying that only machine learning is sufficient. It all says that you have to combine both the approaches, machine learning as well as the application of the rules related to the NLP. Then only you can achieve your objectives. Okay. So it says that at low level, so while doing the tokenization, combine your machine learning as well as the rule associated with the tokenization. Part of speech tagging can be carried out by the machine learning. Chunking, again, purely rules can be employed. To identify sentence boundaries, you can combine the machine learning and the rules. And syntax analysis, again, can be performed by combining machine learning as well as rules. So if you say that, okay, I'll just use the machine learning when my results is not good, of course, you'll have to do the hybrid approaches. Similarly, in order to have the summaries, intentions, entities, again, one needs to combine it with the rules and machine learning approach models have to be combined. And finally, at the sentiment analysis level also, we need to combine the two approaches. That means it suggests the most of the companies which are dealing with the NLP applications, they combine machine learning with the rules, existing rules which have been framed since ages, and we are able to give the better results. That's what they have claimed. Now, using all these things, what advantage it is giving, we are able to test different algorithms and features due to a data-driven approach. This is the thing that different algorithms are available. So you are able to test all these different approaches with different parameters. This is the advantage. Another is that it is once you have created the models, okay, we can include new data to the data sets and which can be used for the training purposes. This is another advantage that you have available some data sets, but new data sets is there that can also be put there and that can also be used. Another advantage here is that since they are the generic algorithms, they can be adapted to other languages also. And by learning and combining various features, statistical based approaches can scale a high degree of performance. That is another advantage of these approaches. Now, when we talk about the machine learning approaches, okay, we have been saying that this has actually revolutionized the NLP, and that is why you find that there is a big boom in the area of NLP nowadays, and most of the companies are actually going for the experts who are good enough in this NLP area. But at the same time, there are some disadvantages that how the features have to be extracted and then combined. Because algorithms, they take a lot of time also. When you execute them, they may consume a lot of time, okay, and it becomes very costly that way, okay. Further, if you are using the data has to be annotated. But the data which you are going to use, we have to pre-process it effectively. So you need actually the annotated data. And annotating the data itself is a very time-consuming, tedious, and error-prone activity. So, and when you are dealing with the text, this becomes more difficult. Even one annotator and another annotator, they may also differ in terms of annotation for the same kind of a data. That is another problem. That means there is an ambiguity. There is no clear thing that, okay, this is the annotation which is the correct one. Two annotators may also have a different opinion. And it requires a lot of human design and features and finding set of rules that can be applied to the new data set. So these are the limited. That means still a lot of human engineering or feature engineering activity is there, and which actually affects the models that we are going to use. So what we see now that from traditional classical machine learning approaches, there is a shift in NLP. And in 1980s, since 1980s, the focus was on the statistical techniques, probability approaches, machine learning. But nowadays, there is a shift toward the use of deep learning for NLP, and that is where you find that it is finding acceptability across all the areas. And we do find that there are a lot of applications which are successfully employing NLP as one of the components. Reason being, first of all, there is an increase in the computational power and parallelization. So you are having a GPU, graphical processing unit, okay, which allow you to apply deep learning, and deep learning utilizes artificial neural network, and now you are able to train billions of parameters. Okay, billions of trainable parameters are possible. It is a possible now, which was not possible earlier when you are using machine learning. So machine learning has the limitation that it cannot handle large scale data, but deep learning approaches, which is the current trends in for NLP. Okay. And another reason is that there is availability of large data sets which allow you to apply the deep architectures. Okay, so there are availability of data collection processes. There is a possibility of training using the deep learning architectures. So this is the current trend nowadays. Okay, machine learning is somewhat taken a backstage now, and deep learning has occupied the main stage. The difference between the two, again, your deep learning has evolved out of the machine learning only. But when we compare these two, okay, machine learning and deep learning, so machine learning actually allow you to learn without being explicitly programmed. Okay, so you're programming it. So you have the data, but the main thing is that here the data is actually labeled data. So even for a training, you are using a labeled data. For prediction also, you are using the labeled data. This prediction actually, which you are doing, okay, you are actually comparing afterward that how well you have actually predicted the outcome based on the model that we have used. So machine learning algorithms are used and learning models are applied, and you are doing the corresponding predictions. I'm not able to see here. It's loading. Okay, so said that it can be supervised, unsupervised, and enforced learning also, where in case of the supervised learning, you have got the labels, whereas in case of unsupervised, we are discovering and it is unlabeled. Okay, whereas in case of reinforcement, it is a, you can say that it is like a carrot and stick approach. So it is based on the feedbacks and rewards. So if it is winning, it is rewarded. If it is losing, then it could be penalized. If we compare machine learning with the deep learning, the difference between the two technologies is that machine learning algorithm works well because of human design representation and input features. So there, if you have whatever features you have defined, okay, they have to be very well defined, and they will depend solely on the human design capabilities. Okay, and machine learning becomes just an optimizing weight to best make a final prediction. So here, the role of the machine learning algorithm is only to identify the suitable weights so that it can make a right kind of a predictions. So the most of the effort goes at this stage, that how well you have actually defined the features so that they can be able to do the right kind of a learning by using machine learning algorithms, and appropriately they can be prediction can be performed. So you can see the main difference between the deep learning and machine learning is that one, in machine learning, the feature extraction stage is important. Whereas in case of a deep learning, that feature extraction is carried out by the deep learning models itself. So that means human being or whosoever is using, they don't have to go into the feature extraction stage. It is the responsibility of the deep learning model itself to extract the features. And what we know that they can extract large number of features also. They can work on the large number of parameters. Now, as we have said that machine learning and deep learning, in between, we also have talked about the neural network. So deep learning neural network is just an extension of the neural network which existed in earlier days also. But if you see, we have been dealing with a neural network which had limited number of nodes there, okay, limited number of layers. Whereas in case of a deep learning, there is the number of hidden layers is more, and you have got an input layer as well as output layers, but the number of hidden layers is minimal. The trend that why we are focusing on this one, which is deep learning here, reason being that nowadays it is being adopted by the NLP community, especially after the success demonstrated by the speech and vision community. So a lot of good results have been demonstrated by the speech and vision by the use of deep learning. And now NLP has also embraced it, and it has also been able to show the good success, especially because we hear the amount of data is very large, and it has been not possible earlier to give very good results, especially if you see your machine translation and all. Still, we find that the machine translation is, a human being is much better for doing the translation as compared to the machines. But now, by the employability of deep learning, this NLP applications are demonstrating very good results. Why about people are often over-specified in but long and the reason that we say that it is not that had the limitations. Okay, so machine learning had the limitation because it depended on the feature description by the deep learning provides the flexible, universal learnable frameworks, and it allow you to represent the world's visual linguistic information also. And the most important thing that you can do here is that you can do end-to-end system learning. You don't have to do in a bits and pieces. You can develop a complete end-to-end system. The trend that we see that Google has noted down that deep learning has now picking up, though machine learning is also rising, but deep learning is also picking up nicely. The only limitation here is that people are not trained in the area of deep NLP, deep learning. Let's see some of the models which are used from the deep learning for NLP applications. So naturally, we have listed various tasks for NLP, okay, right from the tokenization, part of speech tagging, etc. Now here, how are we, and sentiment analysis finally, then how are we going to achieve those tasks by using the deep learning approaches? So first thing, naturally, at the lowest level, if you remember, tokenization we talked about, part of speech tagging we talked about. So first level naturally will be to handling, is about the handling of words itself. And then comes the how are we going to handle the sentences. And then it comes that how are we going to handle the chunk of a text, or you can say documents. And finally, how are we going to handle set of documents. So that representation, if we have to handle all those things, we need some mechanism. So these are the models like distribution representation, convolution neural networks, and we also have to handle text, syntax-based information processing we have to do. We have to handle semantic. We also have to handle the context-based things. So naturally, a lot of aspects have to be handled. So we'll see how deep learning actually is able to take care of all these aspects. So these are the models which we'll be discussing. First is a distribution representation. Then we'll be talking about, because next stage is a feature extraction from the machine learning perspective. So machine features extraction normally is carried out by the neural network models, which can be a convolution neural network model or a recurrent neural network model, or you can be using a recursive neural network. or you can be using the memory augmented strategies also. And then if you see, you have got another thing you have to do. You have to handle the context also, semantics also. So attention mechanisms, unsupervised models, reinforcement learning methods, deep generative models, and either of the models can be utilized to reach up to the final stage. Okay, so first of all, we need to handle the words in our text. Okay, and with neural networks, words are normally represented as a 1/n matrix vector, which is known as a one-hot vector. So any information that you are representing, that actually is represented as a matrix, 1/n matrix, that means one-dimensional array. So it can be a binary vector. Now, if it is a binary vector, then normally you'll see that it has got one in the position of the word ID, and rest all could be the 0 values. So all the words are represented in the form of a one-hot vector. But the vector which we are using here at this stage, it is not conveying any kind of a meaning. Neither it is conveying any kind of a meaning. And then another thing that we have to see is that if there are some similar words, there should be some kind of a similar vector representations also. So similarity between all one-hot vector has to be same. That is important. By following distributional word vector, okay, what we are actually emphasizing on, that word appearing within similar context possess similar meaning. So with this hypothesis, what it uses, the word is represented as a distribution over k latent variables. And we are following the embedding, which are mainly learned through the context. And distribution chosen so that similar words have similar distributions. So there are different approaches which are normally used. Okay, one is a word form. Okay, word can form the rows, or column can represent the context. Cells can represent the co-occurrences. Dimension reduction can be applied to reduce the vector size. So these are the different approaches employed for vector space modeling. So this is an example which has been proposed by one of the authors. Okay. So here you see at the lowest level, these are the words. Okay. So this is one word which has got a vector representation. At the next level, it is concatenated. All the words are concatenated. Your activation function is applied. Finally, since we have to express the word, okay, all the combined words, so we apply the softmax classification, and then we get the prediction of this particular software classification mechanisms. In order to perform, to create neural word embedding, okay, what can be used? Okay, so most commonly tool utilizes a GenSim library. So I think when we will have those sessions, you will come across this GenSim library at that time, and you can use that and see how it can be used for doing the word embedding, how the hot vector is created at that time. This is one of the results shown by the earliest researchers, that they use the 10 nearest neighbor, and according to embedding, they could demonstrate that France is closer to these words, Jesus is closer to these 10 words, and so on. So this has demonstrated that the word distribution is one of the best way. Okay. Now, another advantage here is that they can be trained on the real world text also, because it takes into account the context. So misspellings, slangs, phrases, they can also be easily captured and often assigned meaningful vectors here. Misspellings are also handled here very nicely. So that means unstructured text can be taken from the user, and then we can apply these techniques, and then they can later on you can apply the machine learning models also. Another representation for word which is commonly used, developed by Stanford. Again, this is open source. So you can use a global vector for word representation also. And this model is unsupervised learning algorithm. It utilizes, and it is achieved by mapping words into a meaningful space where the distance between words is related to semantic similarity. And here, training is performed on aggregated global word co-occurrence statistics from a corpus, and the resulting representation shows the linear substructure of the word vector. So you can use this model also for your word representations. Okay. Another model which is used for again representing our words is a word to vec. This is again a popular model. It makes use of a continuous bag of words and skip-gram model. Two models are slightly contrast to each other. In COBOL, it's a neural approach to construct word embedding, and the objective is to compute the conditional probability of the target word given the context words in a given window size. Whereas on the other hand, skipgram, what it does, it constructs word embedding where the goal is to predict the surrounding context words. What could be the surrounding context words given a central target words. So context words are assumed to be located symmetrically to the target word within a distance equal to the window size in both the directions. So you take a word and you create a window, and both the sides you identify that what possible words can be there around this word. So in unsupervised setting, the word embedding dimensions is determined by the accuracy of the prediction. So interestingly, you can construct a high quality of word embedding. For example, if you have used a word like a man and royal, it can create a semantic compositionality like a king. So this is the approach which is being used for a word embedding. Now, when we are using a word embedding, so what we have said that at the lowest level, we actually want to use the words. The limitation of a word is that sometimes when we combine two words, the meaning that it is going to have, okay, may not actually be the one which we use it. Okay, for example, if you are using a hot, you are using a potato, and when you combine them, their individual word vector representation are not suitable since these phrases don't represent the combination of a meaning of the individual words. So that is one of the limitation, and it is highly dependent on the application in which it is used. That means if you have created a word embedding for one application, one domain, you cannot immediately or conveniently use for other domains also. Further, applying negative sampling, which is frequency-based sampling of negative terms, while training the word-to-vector model is also problem. Okay, so we need to do this also. Another is that what should be the size of the word embedding. Now, if we are using a small window size, okay, if the window size is there, then two contrasting words, okay, they may be put into the same kind of vicinity. That means they may not be able to differentiate the difference between the two words. Another difficulty is that it does not take into account polysemy and other biases that may surface from the training data also. So these are the challenges with the word embedding. So if word embedding has a problem, that means the alternate way of handling it is a character embedding. Why? Because in many of the languages, what we know that it is we need to actually take the word, okay, and they can be stemmed also. Okay, we need to what the root word is, and they result in a different kind of new words. So word embedding may not capture syntactic and semantic information, and the tasks like part of speech tagging, named entity recognition, intramorphological informations, the use of a character embedding will be much better. Also, many of the languages, okay, not many, but there are certain languages, they are morphologically rich languages. Even Hindi is a morphology, or Indian languages, if you say, they are also morphologically rich languages. But Chinese is totally dependent on the morphological, okay, highly rich language. And therefore, for these kind of languages, character embedding is also preferred. Another advantage of character embedding will be that it is able to handle unknown word issues also, that is out of vocabulary word also will be acceptable if you are using a character embedding. Now, what are the tools and methods which you can use for embedding? So there is a list of tools which you can go through and use them. And I think while having a hands-on session, you would be able to use them, okay, some of them. Now, once we have created the word embedding or a character embedding we have used, okay, we have to, what we see that it is able to represent the words in a distributed space. And now we also need to have a features, okay. So if we want to apply these deep learning models, then first of all, we need to have the features. So feature extraction, in order to do the feature extraction, we need to apply some kind of a model, and convolution neural network is one of them. Naturally, these features are important from various NLP tasks. Okay, so CNN is considered to be one of the effective choice, especially for the computer vision. Okay? For computer vision, CNN is quite preferred one. Now, for NLP things, okay, for sentence modeling with the CNN, we have to first of all tokenize the words, okay, then they have to be transformed into a word embedding. Then we apply the convolution filter. Convolution filters are applied, and when we are applying, we create a window size to produce what is called as a feature map. Okay, so convolution filters are applied on the input embedding layers, which consist of applying a filter of all possible window sizes to produce the feature maps. And then we apply the max pooling operation, and by applying the max operation on each filter to obtain a fixed length output, and then we also try to reduce the dimensionality of the output. So that after applying this, we get a final sentence representation. So this is a model proposed by Colbert and Westons. Okay, so if you see, you have got an input sentence here consisting of various words, and we have to generate the features. Okay, by using the lookup tables, and convolution layer creates a complete map of the features. Max pooling operation is applied. Then we apply the softmax classification, and a sentence is generated. So for a sentence point of view, it looks like this thing, that this is a text. So if you see all the words, individual words, they are represented as a vector here. Okay, so these inputs are then we apply convolution with multiple filters. Okay, width and multiple feature maps are applied. After that, we apply the max pooling out, and then we apply the dense layer. That means and the softmax function. So there are different ways the CNN can be applied. If we are using we can use a window approach. So by increasing the complexity of the basic CNN, adapting it to perform word-based predictions, other NLP tasks such as NER can also be studied. So window-based approach, what we do here, for each word, a fixed size window of neighboring words is considered. And tag of a word depends on its neighboring words. Then for each word, fixed size window surrounding itself is assumed, and the subsistence ranging within the window is considered. If you are applying a standalone CNN to the sentence, the predictions are attributed to the word in the center of the window. And if you want to apply it to the larger text, then it has to be coupled with another neural network model, that is a time delay neural network model. So fixed size window approach, if you're following, you can handle the small sentences. For handling large contextual ranges to have the meaning, you can combine it with another neural networks. What the limitation here is that after each data point is processed, the entire state of the network is actually lost. So therefore, it is not able to have the complete continuity of the context. Okay, and if there is a fixed length of the vector, so it deals only with those sentences only. It cannot handle the long distances dependencies. So one has to go for another additional models like time delay models or dynamic convolution neural network models. So another type of neural network that can be employed is a recurrent neural network. Here now, because our text is a sequential in nature, images, okay, you have got a two-dimensional figures, but here the text is always processed, is a sequential data. So for sequential data, RNN, that is a recurrent neural network, is a better idea of using. So we can perform the computation of over each token of the sequence, and each step is dependent on the previous computations and results. So here a fixed size vector is produced to represent a sequence by feeding the tokens one by one. And in reality, what we mean that there is a memory. Okay, so the recurrent neural network has a memory. It makes use of that memory concept, and that's why it is able to process. Okay, so this is a mathematical model for the recurrent neural network, and this is how it is trained. Okay, and it also has got a variants. One is the LSTM, long short term memory, where it uses 3 gates, input, forget, and output gates. This is another combination with RNN you can use. Okay. Another similar to LSTM is GRU model, which can be utilized. Okay. So you can use different combinations also. So this is example of your long short term memory model and rate recurrent units. Another variation of the RNN is a bidirectional recurrent neural network. So in RNN, only model the dependence of the current state on the previous state is there, but in case of a bidirectional, it make use of a past state as well as the future states. So that means for text processing, we need a prediction for a missing word in a sequence if you want to look at both the left and the right context. So that way, there you can utilize the bidirectional neural network also. So long short-term memory, as we have seen, that it is a model where it uses 4 gates. Okay, it is a gated cells. Information can be stored, can be written, can be read from the cell like a memory. So this is a design for a long short-term memory. If someone interested can go through it. Maybe in one of the forthcoming lectures, it could be handled in a detail. We are just here only giving a fair idea, brief idea that what technologies are there which can be utilized, where all it is suitable. So according to the researchers, for named entity recognition, RNN is good for language modeling, for machine translation, natural language generation, semantic matching. So you can see that RNN is considered to be a good choice for NLP, a range of NLP tasks as compared to the CNN. So for machine translation, it takes the input sequence of the word in the source language and produces a sequence of word in the target language. So using RNN, you can perform a lot of machine translation tasks, and you will find that many of the systems are utilizing it nowadays. So this is a visual question answering example where given an image, natural language questions have to be answered. Okay. And question is, what is the mustache made of? So AI system is able to answer that it is a banana. Another model that can be utilized here is a attention mechanism. Now here, this technique is inspired from the need to allow the decoder part of RNN-based framework to use the last hidden state along with the information calculated based on the input hidden state sequence. That means previous sequences, the results obtained from the previous sequences are also utilized here, which is suitable for many of the applications, especially where there is a requirement of an alignment. Now, if you see your question answering things, if you see your machine translation, whatever input text you have got and whatever output you have got, there is some kind of correlations. So in that case, some alignment may be required, and in such application, attention mechanism can be comfortably employed. So you can see here that you have got your input sentences consisting of words. You can apply LSTM, and then you have got a aspect embedding here, and further you are actually adding attention component alpha here for finally giving you the outcome. जो भी आपका outcome लेना है. Another model that can be utilized here is a recursive neural network in NLP. So it is similar to RNN. Recursive neural networks are natural mechanism to model sequential data. Just we need to remember that our text is a sequential data. You can see that how this is being a recursive neural network can be used. So here we have got a set of words not very good. So first of all, it takes very good. Okay, it create a new embedding here. Okay, it's combination. Then it combine the next word and so on. Okay, so language normally is seen as a recursive structure where words and subphrases can be composed hierarchy. So non-terminal nodes will be representing by the representation of all its children nodes. Where it can be applied, parsing, okay, phrase level representation for semantic analysis, okay, topic identification, sentence relatedness. These are the applications where recursive neural network has demonstrated better performances. You can use the autoencoder also, where it has one particular single element vector only, which is recursive autoencoder can be utilized there. This is another example for semantic predictions, how it can be utilized. You can use semi-supervised training also. Okay, so this is another approach which can be employed. Another approach is use of reinforcement learning. Now here the machine learning methods are trained agent to perform discrete action followed by a reward. So natural language generation is one example where reinforcement learning can be successfully utilized. Unsupervised learning is used because it makes use of mapping sentences to fixed size vectors in an unsupervised manner. It can be performed. So models are trained using a sequence to sequence framework where the decoder generates target sequences and the encoder is seen as a generic feature extraction. So this is an example of a deep generative model. You can have a variation autoencoder, you can have a generative adversarial application. So these are the models which are employed in the NLP processes for generating realistic sentences from a latent code space. So for language generation, these are the choices. Okay. Another model that we can employ is a memory augmented network. Again, question answering, language modeling, part of speech tagging, sentiment analysis. Okay, there can be utilized easily. So this is an example of autoencoder, how it looks like. That it consists of a feed-forward neural network that learns to predict the input itself in the output. Okay, so there is an input to hidden corresponds to the encoder, and hidden to output part corresponds to the decoder part. So you can also have a deep autoencoder using multiple hidden layers. Reinforcement learning is another way of application to the NLP task, which can be policy based, which can be value based, which can be model based. You can plan accordingly which policy you want to use. Now, when we talk about the deep learning models, okay, then we naturally need to work with some kind of available platforms. So if someone is good in programming and all, they can always work with either of the platforms. So most commonly used languages for deep learning application development is Python, Java, and C++. So if you want to, you have either of the choices. They have got their own advantages. That means deep learning solutions are available in Python, Java, and C++ also. Python, because it has a lot of support is available, and it has got a lot of libraries are available. At the same time, it supports object-oriented as well as procedure-oriented programming. So Python is normally the first choice if someone wants to use deep learning for NLP applications. Another choice is Java, because some of the earlier NLP organization who have been working in NLP, they have actually developed their application in Java. So you'll find that their deep learning solutions are using Java also. Now, Java in that case gives you the advantage of, because the understanding of Java with many people is more. So there, it is able to have the GUI kind of a thing, so rich graphical representation it provides. And it also provides the package services and also the scalability property. Whereas when it comes to C++, it suits those people who actually want to have a control over their software. So if they want to have a total control over their software development process, and also they are concerned with the efficiency of their tools that they are developing, then in that case C++ could be a good choice. So someone who actually is interested in developing a complete solution from the beginning till end, and also want to own it, okay, then they should go for a C++. Other advantage that C++ will offer is that it allow you to do the low level to high level programming. So integration of the devices and all also seamlessly you can do without having any kind of a risk of using the proprietary and other things issues. Okay. It is compatible with the resource-intensive application. So if you are working with a resource-intensive application, want to have an optimized solution, want to have a control over your software, then C++ could be a choice. These are the platforms where not only just NLP, but the deep learning and machine learning approaches also you can use. So Monkey Learn, Alien, IBM, Google Cloud NLP APIs, Amazon, NLTK, Stanford, and all these are actually the platforms which you can actually work upon. So TensorFlow is one of the most popular one, and this is the most popular one because first of all, it is supported by Google, created and maintained by Google, used by Google in its applications also, and it has been adopted by Airbnb, Intel, Twitter also. So it has got good support, so you can always use the TensorFlow. So I think in the lab sessions we have included a TensorFlow, so you will have this particular, you will have the hands-on experience of using the TensorFlow platform. Okay, and it provides end-to-end solution for machine learning. Further, it also includes implementation of Keras libraries. So you can combine with the Keras libraries for NLP applications. Okay, you can do a lot of embedding, experimenting. Also, you can see how the what embedding is done and so on. If you want to install TensorFlow on your system, just use the pip install TensorFlow and you'll get it. This is an example of how you use the TensorFlow. In TensorFlow, how the Keras libraries are used. Now, just see here. This is how the neural network model has been created here. Layer 0 layer, okay, layer 1, layer 1, layer 2, and how they are going to be connected with each other, how the activation function is to be applied, okay, and finally what the model overall will give you the result as. Then we have also assigned the accuracy levels, okay, and it will also do the prediction, that how well the predictions are. So this is an example of a sequential model by using Keras and in TensorFlow. Okay. So what you need to do in TensorFlow, to import TensorFlow SPF, okay, from Keras libraries, pre-processing text, import the text to word sequence. So this is a document that we have taken. Okay, so in Colab, this is available as an example, you can see. Okay, so we want a text to word sequence. Okay, so it just give you the word sequence here. Then next, what we want also to have a one hot encoding also for the given set of words. So it also will be able to give you the encoding for the given set of words. So this is a text, and corresponding encoding also can be obtained from this particular in the TensorFlow by using the Keras libraries. Okay, so this is how you can go. Now, advantage of using TensorFlow is that it is free, it is supported by Google, and learning graph is better here and supports different languages. So support is available, and that helps you in understanding how it is to be used. Another higher level level APIs for TensorFlow is a TF Learn. So these APIs, okay, they have got large number of deep learning models, okay, like convolution, LSTM that we have just discussed. So various learning models it is able to use. So if you want to use these models, you can use a TF Learn also with the TensorFlow. Now, TensorFlow was created by the Google. PyTorch is developed by Facebook. So this is another deep learning platform which you can use. Okay, so it makes use of CUDA and C++ libraries and considered to be robust and flexible also. So main thing is that it uses the GPU, unlike NumPy. NumPy is not using GPU, and that is a limitation. So if you are using NumPy, you can do the machine learning, but you cannot do you cannot use the deep learning models because NumPy does not use the GPU. It cannot. Okay. So PyTorch is another platform which you can use for your NLP tasks. So you have got a PyTorch NLP, just pip install PyTorch NLP and you have access to all. Another Python library is Piano, which is I think now not so well supported, but I think after 2017 I don't see much of the progress there. So it is built, Keras actually was built on Piano, but now it is not having much. But what it says that it is able to offer variety of the NLP tasks like machine translation, speech recognition, word embedding, and so on. Keras library, as we have talked, This is high-level neural network APIs written in Python and is able to run on variety of platforms like TensorFlow, CNTK. CNTK belongs to Microsoft, okay? So it supports multiple GPU training, has a lightweight architecture, and therefore it is considered to be a good choice, and it is being used. So you can just see that how convolution models can be, how it can be created. So from Kera layers, we import the convolution 2D, max pooling 2D, Platons, and so on. So this is examples which you can, I think, we will be working while having the hands-on sessions. Another platform is Chainer. This is a standalone open source platform and supports the CUDA, also supports the GPU. So this is an example. So advantage here is that it is able to demonstrate the graphical graph-based results. That is the advantage of using the Chainer. Stanford Core NLP is traditionally, because they have been working since long in the area of NLP tools, so they have got a rich repository of the tools like part of speech tagger, NERs, parsers, co-reference resolution, etc. So they have got several already production-ready solutions. And they have got optimized versions of part of speech tagging, etc. This is the one which is actually, because they have been working in Java initially, so their actually tools are available in Java. But now they are also including the Python. Okay, so this is used in many of the commercial applications also. Okay, advantage here is because supports many of the human languages. Okay, because they have been extensively working in the area of NLP since long time. Okay, so they are supporting several grammatical tools availability. NLTK, if you're working with the NLP applications, then this is one natural language tool which is very rich in NLP resources. It has got over 50 corpora and lexical resources. Even the WordNet is available, and you can free and open source, community driven. So therefore, this is rich in terms of various libraries related to NLP tasks. How you can use NLTK? You can just import NLTK. Okay, you can do the tokenization. You can do the part of speech tagging. So, and then you can work upon it. Okay, named entity recognition. So, inbuilt library, a lot of inbuilt libraries are available there. This is an example of generating the parse tree. Another interesting platform is a text block, which is an interface to NLTK that turns the text processing into a simple project. Means it is able to handle large scale data. Okay, so it's simple addition of various components, semantic, sentiment analyzer, and other convenient tools can be included there. So normally preferred for the rapid prototyping. How you can use it? Install the text block. Okay, you need to download the corpora on which you want to work. Okay, from text block, import the text block. So you first of all create that first text. You can do the tagging, part of speech tagging. You can find out the tags also. You can perform the sentiment analysis also. So you can see that it is able to give you the sentiment analysis also for a given text. So again, text block is a rich resource for your NLP task. You can find out the language also, what language the particular text is about. It can classify its features also, what text is written about. Okay, again, information can be obtained about the particular text also, be it in any language. It means variety of languages are supported by the text block. Fine. So sentiment analysis libraries are also available here. So advantage here is that it is built on top of NLTK, so it makes good use of NLTK libraries. Okay, it provides language translation and detection, which is powered by Google Translate actually. Limitation here is that it is slower as compared to STC, but faster than NLTK. So these are things which you can do: noun phrase extraction, part of speech tagging, sentiment analysis, and you can see a large range of activities. So different platforms are there which you can utilize. Another one is a GenSim. So this is used for the library for document similarity analysis, and all algorithms are memory independent with respect to the corpus size. So therefore you can use different variety of corpus sizes it can work upon. Topic modeling and document similarity comparisons. You can use GenSim also for your NLP task. Another is a SPECI, which is an industry strength library and claim to have been doing better than many of the existing tools. Okay. Presently, it is working on English language. Good thing is that it is faster. Now it is supporting many other languages. Initially, it was developed for only English, but now it is supporting large range of languages, 59 plus, supporting 46 statistical models for 16 languages, pre-trained word vectors. So you can use this also. If we compare different platforms, so TensorFlow is considered to be the most popular as compared to all others, and you can explore others also. Some of the pre-trained models for NLP can also be utilized right from the end to end. If you want to have a solution, GPT-2, BERT, and Elmo. This can be also used. GPT-2 has been now replaced by GPT-3, which is developed by OpenAI Lab. Okay, and now the number of parameters that they can train, it can work on 175 billion parameters. Okay, so it says that it is able to demonstrate very good performance in translation, answer questioning, and completing sentences, and even it could fool 88% of human evaluators. That's what their claim is, into believing that it generates a news article written by human letter. So this was a text which most of the people believe that it is written by human being. So BERT is another bidirectional encoder representation from transformers model, which is pre-trained and again developed by Google. So Google has been contributing significantly, you can say. Again, if you see the performance levels, it uses 800 million words, then BERT Large uses 2,500 million words. Okay. In 2019, Google search started applying BERT model for English language, and after 2019 December 9, it has been adopted for 70 another. So this is another project by ExcelNet, okay, pre-trained model. Elmo is another model, okay, which is developed by NLP. This is a deep bidirectional language model, and this can also be utilized. Now, advantage of deep learning approaches that we can conclude is that they have the capability to learn complex features from data. Okay. And they can save significant effort on constructing features. Difficulty here is that since it is using neural network, it is difficult to understand what is happening there. Further, there is a steep learning curve. That means people need to learn them. Okay, and it also suffers from a clever hens effect, which refers to model achieving impressive. Okay, you get very impressive result, but ultimately it could be also useless. So something you get the answer, but that has no significance in reality. Also, if you see in NLP, some of the things which really, the results which are given by these NLP solutions, okay, they end up in some kind of a comedy of errors only. Or to the worst situation, if seriously if it is taken by the government organization, they can end up in a bad policies also, and eventually they can also be bad for a business. So something which is difficult to really comprehend, or really we have to be very cautious, is that we cannot totally rely on these tools. Okay, for example, we can see that this is a movie which for which the captions are to be generated automatically, and the song is "Behne De Mujhe Behne De," and the translation given by the automatic machine translation is not acceptable. If you can see, "Give sisters, give me your sisters," totally not acceptable. So with this, I think we can take some dig at machine learning, artificial intelligence. Some humor is always there about these technologies. That in machine learning, what society thinks we are really making a lot of money. What the friends think that we're doing the very extraordinary job. What parents think that he's working in a very hi-fi industry. What the programmers, the peers, they think that I'm doing very good research work. What I think that I'm just doing some kind of graph generations, evaluating the results. And naturally, if we are using the libraries, perhaps we are doing something very limited. Few more things which are just on a lighter note side only. Okay, so behind artificial intelligence, we say that there is a machine learning. Behind machine learning, basically there is lot of statistics, lot of mathematical models which we need to understand. So in one of the talks, people did ask that what if they really want to go for a hands-on complete sessions and all, then what online courses are available. So I put these courses also. If someone is interested, can join those courses also. If someone really want to get into deep. Okay. So some of the references, not all, because there has been a very large number of references considered. And with this, I thanks the audience. And
thank you very much, ma'am.
Thank you
for providing us knowledge about machine learning trends in NLP. So you covered machine learning as well as deep learning as well as NLP. So now I think all the participants got introduction about all these things. Yeah. So yes, any question from the participants now? Is there any question? Any query?
So I think our next speaker is waiting.
Ma'am, one question. Ma'am.
Yes.
Good afternoon, ma'am.
Good afternoon, sir.
Just I want to know that in a specifically natural language processing, suppose specifically like a handwritten text recognition, if I want to use a particular classifier, then which one is the best?
Because that you're asking is related to image processing. So you
yes,
have
yes,
to, yeah. And I think here we are focusing more on text data.
Yes, text data.
Yeah. So I think there is one session by Dr. Prakash Chaudhary.
Okay.
Because he's working in the area of written text transcriptions. Okay. So because they will be talking about image captioning. Okay.
Okay.
And how the feature extraction is to be done for the text. In different languages, because they have worked in the area of Manipuri language and all. So I think they will be a better person to answer your questions.
Sure, ma'am. Thank you, ma'am.
Okay.
Yeah, thank you.
So you please attend that session surely.
Sure, ma'am.
Okay.
Hello, ma'am. Good afternoon, ma'am.
Good afternoon.
Yeah, ma'am. Actually, in suppose sentiment analysis, we have to analyze the positive and negative. Okay. Suppose neutral, whatever. And we have many data sets. So how we will give the labels? Like manual give the labels, or we have some techniques to give the labels?
See, if you are using machine learning, you have the possibility of giving manually, right?
Okay.
But when we talk about the deep learning approaches, you're not giving manually those labels.
So it will be automatically done in deep learning, right?
It will automatically has to be detected. Then the results that you get, because see, you will be actually fine tuning your parameters for the neural network. Okay,
So
you are using.
How we know, ma'am? How we know deep learning has done correct labeling? Whatever.
So you always you know that as a human being, you are able to figure out. No, so once you have trained the model and that model is acceptable to you, then you consider, yes, this is the model. This works correctly for all the cases. So you have to train it first of all yourself. It cannot. If you are using a machine learning, naturally you have to label it. Okay. But then labeling is carried out only for a limited set of sentences which you have done. If you add something new which is not there, naturally it may not give you the desired results.
Ma'am, is there any hands-on session
Yeah, we have included. We have included.
Then we will, I think, understand.
Of course, yes, because that is one of the need of the hour also, that you should be familiar with the hands-on sessions also. Okay, so we have scheduled that also.
Ji, ma'am. Thank you.
Okay, and also some of the experts which we have, okay, who are from industry especially, they are working on a real-time projects.
Okay.
Okay, so they will be in a good position for you to answer your those maybe a lively or on at that time also they can conduct the hands-on session for you to explain your ideas
Okay. Thank you, ma'am.
because they are working on the live projects.
Okay. Good.
Ma'am, can you please explain the text limitation?
See, I think our next speaker is waiting now. So we have a complete session by Dr. Jyoti Srivastava on NLP. Okay, complete session because something which you're asking is requires that we need to take the complete some. We have devoted no, some time on those topics. Okay, so your all the NLP task related issues will be handled purely in the lecture on introduction to NLP, which will be delivered tomorrow. Jyoti?
Okay. Thank you very much, ma'am. So thank you. Now we have our next speaker online. So now I would like to introduce our next speaker. He is Dr. Asif Iqbal from IIT Patna, who will deliver his talk on deep learning for sentiment analysis. So here I would like to introduce Dr. Asif Iqbal. Asif Iqbal, he is an associate professor in the Department of Computer Science and Engineering in IIT Patna. So prior to joining IIT Patna, he has worked as a postdoctoral research fellow in University of Trento, Italy, and Heidelberg University, Germany. His research interests are in the broad areas of AI, NLP, and machine learning. He is the recipient of the Best Innovative Project Award from the Indian National Academy of Engineering, JSPS Invitation Fellowship from the Government of Japan, and Visvesvaraya Young Faculty Research Fellowship Award from Government of India. So here I welcome Dr. Asif Iqbal from IIT Patna to deliver his lecture. He is actually very well-known expert in the area of NLP. So we are really privileged to have such a speaker in this course. So please, Dr. Asif Iqbal, now you deliver your session.
Okay, so thank you. Okay, am I audible to you?
Yes.
Can you hear me
sir.
properly?
You're audible.
Okay, so thank you for the introduction and thank you for inviting me. So quickly let me know. I think I am not very much sure whether my voice is I- because the network is just fluctuating. So let me try. So, but so far I am audible, right?
Yes, sir. Yes, sir. You're audible.
So any participant, so if you hear any problem or if you cannot hear me properly, so immediately just let me know. So
Yes, sir.
I will
Fine,
now,
sir. Fine.
so I will now share my screen and then maybe we can continue discussions. So can you see my screen?
No, sir. Not now.
Not now. So now can you see? No?
No.
Oh, but it is showing it is shared. I don't know what is happening. Let me try it. Okay, so So now also you cannot see my screen?
No, sir, your screen is not visible.
Oh, but it never happens, I don't know. So I take classes. So is there anything from your side? But I'm able to share. It is showing that it's sharing the screen.
Sir, please click entire screen, sir.
Yes, now it is visible, sir.
Now it is visible?
Yes, sir.
Okay. Okay, so thank you very much again for inviting me, and thank you all for attending my lecture. So I'll be mainly talking about the sentiment analysis, which probably many of you know that this is an important area of natural language processing. So I will mainly focus on deep learning based approaches, that how deep learning techniques can be used to solve the sentiment analysis problem. So going forward, so this is the brief outline of my presentation. So I will briefly introduce the sentiment analysis. Then mainly I will talk about fine-grained sentiment analysis, which is also known as the aspect-based sentiment analysis. Then mainly I will talk about how CNN, how RNN, then long short-term memory, attentions, memory network. So all these methods can be actually employed to solve very important problems related to sentiment analysis. And when you talk about sentiment analysis, there are certain concepts. For example, the context plays an important role. So how can you learn the context based on the target? So what is target? We will discuss that. So target here is the aspect. Okay? And there could be the dependency between the aspects, that also we'll see. In India, multilinguality, cross-linguality are very important because we have 22 officially spoken languages, and the number of languages is approximately in India will be 1900. Okay? So the multilinguality plays an important role because 60 to 70% of the populations don't know English. So how to make these services available to those people who are not comfortable in English language? So I'll show some of the work that we have been doing in multilingual sentiment analysis, and finally the takeaway. So typically, to define sentiment analysis, we can say that sentiment analysis is basically the task of determining the orientation of opinion mentioned typically in a piece of text. That means if a particular person has written or expressed his or her opinion in the form of written text about, let's say, about a product, about a movie, about a schemes, about a college, about a university, it can be opinion, can be anything. Okay, and from that written piece of text, the system should be able to identify that whether the underlying opinion of the author is positive, negative, or neutral. There is no opinion, and sometimes there can be also conflicting of opinion. Conflicting opinion, I will show you the example, but sometimes you are not very much sure. Some parts of a particular, let's say, if you talk about the government, many things you may like, many things you may not like. So you have a kind of, let's say, conflict of opinion about any particular situations. But nowadays, not only text, so I don't have time to talk about, but we have been deeply working on the multimodal sentiment analysis also. If you look into our recent publications since 2018, so we have published quite a few papers on sentiment analysis and emotion analysis related to multimodal sources. So multimodal means in this case not only text, but if you have the input in the form of video, in the form of audio, in the form of images, so those mediums also play an important role. because nowadays you see that people have a tendency, particularly in the social media, rather than writing. So people prefer much to post a particular pictures, for example, or a particular video. And also these, that is the reason why. So how can you understand the opinion of the person from his or her images, or the speeches that he has given on the video, by looking at his different expressions. So those kind of trends are also nowadays very prominent, and we are also investigating on those fronts. So we can say that sentiment is basically finding the orientation, opinion, generally text, but it can be also audio, video, or the images is also possible. So now, as I mentioned, this is not a very new thing. So what others think has always been a very important piece of information to all of us. For example, if you go back to the before this internet era, so if you go back before 2000, let's say 1980s, or before 1990, the internet was not so popular. After 2000 only, the late in 2010, 11, so you can see that a lot of social media sites have started to emerge, a lot of e-commerce sites have started to emerge, right? But if you go back during 1960s, 17, at that time, also people used to give their opinion, right? The people were electing their leaders. Students were also taking admissions in a particular college or university, and people were buying, let's say, cars, televisions, radio, many things, right? So at that point, what people usually used to do. So let's say if you go back 1970s or so, and if you wanted to buy a particular, your parents or maybe their parents, if they wanted to buy any car or any particular televisions, for example, they used to ask those people who already have that particular product, right? That particular product means they used to ask to the people who have that same televisions, for example, or let's say same radio, for example. And then we used to ask them that, okay, or car, for example, they used to ask their relatives, or let's say their colleagues or their friends who are experienced in for using that particular kind of services or the products. And based on those opinion, that what the actual user said, based on that, we used to decide at that point in time. Our parents, or let's say their parents, used to decide like this. Or for example, at that point in time, also people were used to take admissions in different universities abroad also, let's say Stanford, Berkeley, Oxford, Cambridge, if you say. So how people used to go there to study. Again, it was based on by discussing with the teachers, with your own teachers, or let's say with someone in your family, if they have already studied there, or your seniors from the, let's say, colleges or schools, if they have already studied there, we used to have a discussion with them and try to get the idea that what kind of university it is, what is the strength of the universities. If I wanted to study, let's say, engineering, then in which engineering it is better, or let's say if you wanted to study science, which particular science stream is better. If you wanted to do PhD, then which professor is better, which professor is publishing good papers. So everything was based on the interactions at the physical level, or you wanted to talk to the person who are experienced in that particular area, right? But nowadays, if you see in today's world, we hardly do that. If you want to take admission in any good university, so you have lot of information available in the web. You have lot of information available in the web, if you want to work with a particular professor for your PhD, you can easily go through his profile, get his publication details, and then if it interests you, then only you can approach them. If you want to go to Stanford or Berkeley, if you want to do research in, let's say, natural language processing, everybody knows that Stanford NLP has a good group, Berkeley has a good group, MIT has a good group. So in UK, what is the good universities of NLP? So lot of opinions. You will see that the students are giving their opinion in different forums, and those particular informations are very important nowadays to us. And we don't ask anyone. We look into those kind of opinions that people have written, and based on that we make some decisions. But now what is the problem nowadays? So we have a lot of information. There is no scarcity of the information. But the problem is that the time, you don't have time to read each and every opinion that the different people have written about a particular product. Let's say nowadays if you see a popular brand, let's say Samsung Galaxy phone, if you want to buy, and if you see that Amazon reviews, if you see the Flipkart reviews, if you see the eBay reviews and other e-commerce site, you will see that lot of reviews are available. Many reviews, maybe sometimes it can be 5,000 or so if there is a popular product. Now, as a user, as an end user, so if I am looking or exploring and to decide whether to buy, whether it will be better for me to buy Samsung particular brand, Galaxy, let's say, phone, then I will see these reviews of that particular product, and let's say I will read at most 50 reviews, 60 reviews, or let's say 100 reviews. And if there are 5,000 reviews available, I don't have time to read all these 5,000 reviews one after another, and then try to identify that, okay, out of 5,000, maybe 4,000 people are saying positive. So they are saying this is a very good phone, so I should buy it. So that time we don't have. Hardly we read 50 reviews or maximum 100 reviews. And if you say that, okay, out of 100, mostly people are saying positive or negative, and based on that we decide. But this is not always perfect, because if you look into these two scenarios, scenario 1 and scenario 2, you see that, let's say any particular person needs to buy a phone. He was browsing Amazon.in and found 1,000 reviews for a particular phone. Now, there can be 850 negative. If you say that out of these 1,000, in the left scenario, it is shown that out of this 1,000, 850 are negative, 100 are positive, and 50 are neutral. So what will be the overall sentiment? We can say that out of 1,000, 850 are negative, so negative are dominating, so the overall sentiment can be negative. On the other hand, in scenario 2, if you see that 420 negative, 480 positive, 100 neutral, again here positive, in this case, positive is more, so you can say that a positive is more, so out of 1,000, 480 are positive, so overall the sentiment can be positive. This is a very trivial decision that we can make. But now in the scenario 1, if you see that all the 100 positive reviews out of 1,000, if they appear at the very beginning, we search for the product reviews. There are 1,000 total reviews, and I read the reviews from 1 as for the ranking. Okay, the first review I read, second review I read. So likewise, I read until let's say 100 reviews, and you see that all these 100 reviews are positive. And then I say that, okay, I read 100, everyone is saying positive, so this is a good product. So I will be tempted to buy it, which is not correct. Why it is not correct? Because after these 100 reviews, if you keep on reading the remaining reviews, like 101, 102, 103, for all the remaining reviews, you see that mostly they are negative. So that means what? Because you did not have time to read the 1,000 reviews, you had read all the 100 reviews, and all these 100 reviews incidentally are positive. So you had formed an opinion which is not correct, right? On the other hand, in the second scenario, scenario 2, if you see that out of these 480 positive reviews, if 100 reviews are not genuine, genuine means they are misinformation. That is possible. So you know that nowadays misinformation, fake information is extremely popular topic. So this misinformation can also happen in case of reviews also. Because when the users write the reviews, you don't have, as an end user, when you read the reviews written by other users, you don't have any way to understand the motive of the authors. Whether the author has intentionally written something bad about the product or written something good about the product only to promote their product or demote the other products. They can write intentionally any positive reviews, any negative reviews. But as a customer, when I read these reviews, I have no way to understand the motive of the authors. So that means if you have a problem with the reviews itself, if they are not genuine, and if you are making a decision by reading that, then your decision is also not correct, right? That means the out of 480 positive, if 100 are fake, then 380 are actually positive. So overall it should be negative because 420 are negative reviews. And that information we are missing, right? So now in scenario 1, so tackling scenario 2, if 100 reviews are fake, is itself a difficult problem to identify. Okay? And this discipline is known as spam opinion detection. But let's say the scenario 1, if you want to solve, then you need a practical system, automated system, okay, that will have a kind of artificial intelligence enabled systems where you can input all these 1,000 reviews, and in the output you can get an idea that okay, out of these 1,000 reviews, 850 are negative, 100 are positive, 50 are neutral. So these information you want to get. Now as a end customer, I don't have to read each and every reviews manually. Rather, I have a system and every reviews will be passed there, and I will come to know about the polarity value or the sentiment values. And then based on those sentiment values, I will be able to make a decisions. So this is what sentiment analysis does. Okay. So now when we talk about sentiment analysis, there are many challenges. Okay. For example, if we limit ourselves only to lexical level features, okay, you see the first two examples, this movie is not good and no movie can be better than this. The first one is negative, but the second one is positive. However, there are a lot of words are similar to each other. For example, this is a common word, movie is a common word, not and no are very closer. Okay, good and better are very related. So see, however, the review 1 and review 2, they are very close with respect to the lexical level features. Their sentiment are different. Then people when write the reviews, they write in many different ways because they have different styles of writing. Different people have different styles, how to capture them. So for example, in this case, there are 3 examples shown about the phone product. And you see that each of them is negative. However, this negativity has been expressed in different ways. So you have to capture that. Even when the people write their reviews, they write the product name in many different ways. Sometimes people write Google phone, sometimes people write G phone. So how to know that the reviews written for Google phone and the reviews written for G phone, they are actually the same product? Okay, for that in NLP there is a very important problem which is known as the co-reference resolutions. So you have to know that G phone is an object and Google phone is another object, and they map to the same concept. They are typically the same object, but they have different mentions. Okay? This is co-reference problem, which is very important in natural language processing. Now, if you believe that, okay, I can do sentiment analysis, or what is the challenge in sentiment analysis, I will simply keep the dictionaries of positive words and negative words, and then I will simply do sentiment analysis. But this cannot be possible. If you look into this example, the food is very cheap versus the service is very cheap. So in this case, you see that this cheap is a word. In the first case, typically it is positive. If the food is not expensive, you say it is good for us. But if you say the service is very cheap, then it is negative. So you see that in the dictionary now, if you have a word like cheap, so the meaning, its positivity and negativity, you can see depends on the context. Context means in the surrounding words that also appear with this particular word. You should know that when this particular word cheap appears with food, then it is positive. And in this case, when the same word appears with service, then it becomes negative. That means depending upon the context, the meaning of a same word can change, and you have to capture it. So merely keeping dictionary of words will not solve your purpose. And lastly, as you have mentioned, the reviews can be fake also. They may not be genuine. And then how to identify that the authors has intentionally written something bad about a particular product or about a particular event. We have to know it. So with these challenges, now if you look into the whole sentiment analysis problem, then we can say that sentiment analysis can be done at various levels. It can be the coarse grain sentiment analysis or fine grain. It can be done many languages. For example, it can be on English, Hindi, French, etc. It can be carried out for several domains, for example, e-commerce, social media, finance. Typically, sentiment analysis before 2014 mostly were feature engineering based approaches, but nowadays mostly people are using, researchers make use of the deep learning methods to solve sentiment analysis problems. Now its application is enormous. Its application is everywhere. In everyday life, you'll find it is extremely useful component in e-commerce, in politics. In politics, it is useful because it gives an idea that about the different politician, about the trend of a particular political party or particular electoral situations. Security is very important because extreme negativity sometimes can cause to the problem of law and order situations. So, for example, if you can monitor that there is a strong negativity is emerging, the sentiment is emerging for certain event, then that can be an useful information to maintain the law and security. And then there are many sub-problems to this. So we'll discuss each of these sub-problems in the next slides. Now, what are the sub-problems of sentiment analysis? One is that you have to know at first that what are the proper texts for doing sentiment analysis. If you say that sun rises on the east, so you don't have any sentiment in it because it is a factual statement, right? So it is an objective statement. So subjectivity concept, that means wherever the people are expressing their the state, or you can say that different mental states, okay, that actually are the candidates where you can get some kind of sentiment. So at first you have to identify what is the objective text, what is the subjective text. And once it is subjective text, then you try to classify it whether it is positive, negative, or neutral. So subjectivity analysis at the beginning, you can discriminate the text between subjective and objective. So that will help you in the latter stages. Then thwarting, for example, is an interesting problem to say that impressive story, good acting, however, it did not meet my expectations. Now, in this case, you can see that impressive story, good acting. So all are positive words. But as soon as you use the word however, you see that your polarity changes. So this kind of problem are known as the thwarting problem. Because the small portion at the end of the sentence completely changes your sentiment value. Sarcasm is obviously a very hard problem. If you say that a movie is awesome to put you to sleep, so in this case, awesome is a positive word. However, this particular statement is not positive, it is a sarcasm. How do you identify that? Then humble bragging, for example, if the person is saying, okay, my life, very popular person, let's say, is saying that my life is miserable. I have to sign 300 autographs per day. Now, miserable is a negative word. However, the person who is speaking here is saying that he has to sign 300 autographs per day. So signing 300 autographs means he's a very popular person, so he has to sign. So that means he's feeling proud, but he's expressing in a different way. Then discourse plays an important role. For example, in this case, you see that although is reversing the polarity of the movie, then sense plays an important role. If you say scene 1 is a deadly spinner, the campus has deadly snake. Now in this case, you see that deadly is the same word, but in the first case it is positive, second case it is negative. And nowadays, the intensity also plays an important role. And it helps a lot, and it is an important information for making a better decisions. Let's say if you ask your friend that how was the movie, and one of the friend is saying that the movie was okay. That means movie is not bad, so it is positive. The other friend is saying that a movie was good. So now we can say that okay, you are now tempted to look into the movie because your friend is saying it's good. So okay and good, there is a difference. And if the other friend is saying that okay, movie was awesome, so then you say that okay, you get an idea. Okay, surely you have to see that particular movie. So now you see that when you present the informations to the end users in this manner, you see that intensity will be very crucial. Okay, good, awesome, all are positive. However, the scaling of positivity, the strength of positivity are different in two different expressions. So how to identify the intensity from the written reviews and how to incorporate those for measuring the to take informed decisions. So these are all the sub problems of sentiment analysis. Okay? And each of the problem is very interesting, and the problems are challenging also. And they will have the influence on the final sentiment analysis predictions. Now we'll talk about the granularity of the sentiments. So what do you mean by the granularity? Typically, the sentiment analysis, if you look into the literature, so mostly it has been done either at the document level or the sentence level. That means if you are doing the review analysis, the whole review written by a particular person, you pass it to a sentiment analyzer. Sentiment analyzer will give you whether the person is saying positive about the particular review or not. This is the document level. Now, document level will not be always perfect. It has certain problems because if it is a document level, in the document level, let's say there are 5 sentences, you will see out of 5 sentences, maybe sometimes in the first sentence, the person has speaking something, let's say about a movie. So saying about the actor, actresses of the movie, and the user is saying that the actors have really acted very well. And then second sentence you are saying, however, the story is not good. And then later on you are saying the movie theater is also could have been better. So now if you pass these 3 sentences together to a sentiment analyzer, so overall what will be the sentiment? 1 is positive, 2 are negative. So you can say 2 are negative, so ultimately it will be negative, the majority principle. But which is not correct. So now in the sentence level, what is happening is that if you see that, okay, what is the polarity of the first sentence, that you present first. And the end customer, if he is a fan of those kind of actor or actresses, even if the film is not very good, story is not good, people watch that kind of movie. That also we do in our real life. You have seen that if you have a fascination to particular actors, so even if the story is not good, you want to see that, right? So the sentence level informations always will give you the very the better informations, because it analyzes the sentences one at a time and predicts the sentiment. But that also may not be sufficient. The sentence level also may not be sufficient, because if you look into this example, its battery is awesome but camera is very poor. So in this case, you can see that if you do a sentence level sentiment analysis now, then you see there is a positive word awesome, there is a negative word poor. So one positive word, one negative word, so plus and minus, it becomes zero, it becomes neutral, which is not correct. Let's say a particular user who wants to buy this product, and he wants to buy a product with good battery life, then he will be interested to buy it because battery is good. On the other hand, another user who is more fascinated with the camera, the picture quality, let's say. So they're saying the camera is poor, that means he will not buy that particular product. So that means you see that in this particular review sentence, two features of the product have been talked about. Two of these features are known as the aspect or the attributes. Two attributes have been talked about. One attribute is the battery, or the aspect is the battery, and another attribute or the aspect is the camera. For the battery aspect, the opinion is positive. For the camera aspect, the opinion is negative. And now, depending upon the end user's requirement, whether battery is more preferable to me and if camera is more preferable to you, then you decide that whether to buy it or not. This information we cannot get using a sentence level sentiment analysis. And this problem is known as the aspect-based sentiment analysis, that analyzes the sentiment with respect to each attribute or each entity mentioned in a piece of text, which is very important for making any business decisions. Okay. Now going forward, so what will happen here? So positive will be battery and negative about the camera. That should be the actual information. So this aspect level sentiment analysis has two tasks. The first task is you have to identify what are the aspects or what are the attributes. For example, in a restaurant review, if you say that, okay, I like the service of the restaurant and the staff, but not the food. So now there are three aspects you have talked about. One is the service, then the staff, and the food. So given this particular sentence, you have to identify the service is an aspect, staff is another aspect, food is another aspect. And that you can do using a sequence machine learning algorithm. You have to present this sequence, and every word you have to determine whether the first word is an aspect term or not, second word is an aspect term or not, third word is an aspect term or not. It is a kind of named entity recognition. Okay. Then it can be for sometimes multi-word also. If you say that laptop review, in this case there was some form factor and great battery life. In this case, you see that form factor together is a multi-word, and this is an aspect. Battery life together is an aspect. So the first problem is known as the aspect of extractions. After you extract it, then the second problem is the sentiment classifications or the polarity identifications. Now, what can be the possible polarity for the sentiment values? Positive, negative, neutral, and also there is another one is the conflict. So, for example, if you know that okay, I like the service and staff, and if you have seen already, the service is an aspect, staff as an aspect, food is an aspect, then you can say that service can be positive, staff is also a positive, okay, and food is a negative. So this is the task of polarity identification or sentiment classifications. If you say that okay, I did add a SSD drive and memory, in this case the aspect term are SSD drive and memory. For SSD drive also the opinion is neutral, memory also is opinion is neutral, because you are neither saying positive nor saying negative. But in the third case, if you say the RAM memory is good but should have slug for 8 MB instead of 4 MB. So RAM memory is your aspect term. You see that initially you had positive sentiment, but then you are reversing your polarity. So you have a conflicting opinion. So these two typical problems you have to solve using for the aspect-based sentiment analysis. So some more examples of aspect-based, what actually we want to find out from this. Let's say in the left side, there are different review sentences. If you say that the speed, the design, it is light years ahead of any PC I have ever owned. In this case, you see that speed and design are the two aspects and both are positive. Tech support would not fix the problem unless I bought your plan for $150 plus. So in this case, tech support is a aspect term, its polarity is negative. Then if you say certainly not the best sushi in New York, what is the restaurant reviews? So in this case, the aspect is sushi and place, and your opinion is conflict and positive. But in this case, the situation is more difficult. If you say it was very expensive for what you get. Now, in this case, you see that the word expensive, okay, we did not mention, nothing, no aspect term is mentioned here. You are not saying anything, that the price is very expensive, you are not saying that. Price can be an aspect. That is not directly mentioned in the text. But you have to identify of the word expensive, that expensive is a word that is related to price. So price here in this case is an aspect term that you have to identify. So this is known as the implicit aspect term identification, which is comparatively a difficult task. Then if you say that, okay, I enjoy having Apple products, so in this case, you see that you are saying that you are talking good about the Apple product, but you are not saying anything, anything about whether it is which particular product you are referring to. That is not clearly mentioned here. Okay, so there is no aspect term. So now I will finish this part by this last example. If you see in this example, these are the reviews of a particular product, camera. And if you do the sentence level sentiment analysis, you see that the product will have a rating around 3.5 or so. Because you see that zoom is excellent, LCD is blurry, great value for price, although display is poor, picture quality is amazing, battery is dead pretty quickly. So different aspects have been talked about. So if you do the overall sentence level sentiment analysis, the average, it will have a rating of 3.5. Now let's say I am a customer and I read this rating 3.5 or 3 or 3.5 out of 5. And if I get this, then what will be my impression about this product? My impression will be, okay, the rating is not very good. It is an average rating. So maybe I will not buy. But let's say I as a customer wanted to buy something which has a good zoom. Or let's say I did not want to pay much. Or I wanted a good picture quality. So in this case, you see that looking at the left part, the overall rating, we are missing those information. Because, however, the zoom was excellent. The picture quality was amazing. The price is also, price-wise, it is good. Those informations are missing in the left part. And looking at these, it confuses me and I'm not able to decide. But if you provide the right part, let's say the price now will be 4.5 in the scale of 5, zoom 5, picture quality 4.5. So the customers who is more interested in zoom, picture quality, does not want to pay much, will definitely buy this product. But the persons who are more interested in the battery life or the display, they're looking at this low rating, they will not definitely buy this. So now which one is better for decision making? It is obvious the right one, the aspect level sentiment analysis, give you more information compared to the sentence level sentiment analysis. This is why we need to consider the aspect level sentiment analysis. Okay. So now let us see that what are the ways to solve these particular problems. Like any other sentiment analysis, here also we can solve this using typically a feature-based machine learning algorithm or a kind of which is traditional machine learning, you say, or nowadays the deep learning model. If it is a traditional machine learning, so the input will be a document or sentence. You have to identify the set of features. And these features will be identified by a designer like you. You have to identify that, okay, which n-grams are important. You have to identify that which lexicons to be used, whether it is NRC lexicon, whether it is NPQA lexicon, whether it is a centi-wordnet. There are many lexicons available. Which lexicon to use, how to extract the features. So all these features analysis you have to do by yourself, feature engineering part, with the help of the algorithms. And then you choose one of the algorithms like SVM, decision tree, etc. Finally you predict. So the most complicated part is this part here, the feature engineering part. But if you now move towards the deep learning architecture, you see this feature engineering part is missing. We don't have to do it. Rather, what we can do is that the document or sentence will be inputted. There will be the vectorial representations of each of these sentence or document. We call it as an embeddings. Then there will be a deep learning models. Finally, there will be the classifications. So you see that now in deep learning, we don't have this feature engineering part. And because of that reason, you can say it is a kind of end-to-end model. So give an input document, give its good embedding representations, and finally you get the predictions. Okay. So CNN, if you think that CNN is a very promising method for doing sentiment classifications, not only sentiment classification, but for any classification problem, because it is a good feature extractor algorithm. So we can use it for sentiment analysis also. So how to do it? For example, CNNs, let's say in this case, if you say that the movie is very good, so now in this case, the movie is a sequence of words. What you have to, overall, you know, as an expert, it will be positive. Right? Now, how CNN learns this, it will be positive. So in CNN, let's say if we say that, okay, n-gram as a feature. So in this case, n-gram means we consider the bigram. So 2 words at a time we take, we consider their word embedding representations, and we pass it to a feed-forward neural network, and we will get a representations for each of these bigrams. That is how at the beginning we were doing. So the movie is considered first, then movie is, then is very, then very good. So you see that the window is slided, okay, with a stride of size 1. Stride of size 1 means you are only skipping only one positions to the right and then you are considering 2 words at a time. So in the output, then you get the 4 different representations, right? One for the movie, one for movies, one for is very, and the other for very good. These 4 different diagrams. Then what will happen now? Let's see. Then in CNN, what is done is that after getting this representation of these diagrams, so these are all the feature representations. Now you have to identify that, okay, out of these features, what are very important that you have to identify. And that you can get through the pooling operations. So pooling is a kind of operation that will pool the important features. Okay. So like in this case, if you consider the first dimensions, like for each of these 4 different diagrams, like 0.4, then a 0.1, 0.2, and 0.9, you see that 0.9 is maximum along this first dimension. So 0.9 would be, if you are using max pooling, then 0.9 will be extracted. If you are using mean pooling, then it will be minus 0.1. Then along the second dimension, again 0.5 is highest, so 0.5 will be the maximum along these dimensions. Third, 0.9 is the maximum, and the fourth, again 0.9 is the maximum. So now you see that after pulling out the important features, you get another feature representations. Okay. Now you pass it through a feed-forward neural network and do the classifications. Now why it will be a kind of, why it will be the positive and why not negative, why not neutral? Because if you look into these particular features that you are inputting to a neural network, you see that out of these 4 features, the 2 features like 0.9 and 0.5, these 2 are coming from very good, this particular diagram, right? And 0.9 is coming from the movie, and this 0.9 is coming from movies. So you see that out of these 4 features, 2 features are coming from a single diagram, and because of that reason, this is dominating feature over the others. And if this is dominating, we know that this will have higher effect compared to the others, and because of that reason, it becomes positive. Okay, this is how the CNN works. Now, in CNN, I'll talk about one of the methods that we have done for, we did in 2016, and we have solved not only the aspect-based sentiment analysis, but the sentiment analysis at the sentence level also. And we did it for English language, we did it for Hindi also, and we did it for movie reviews, product reviews, tweets, etc. So, but our algorithm was different. So it is based on CNN, but also we had made some augmentations to the CNN. So what are the changes we have made? So you see that typically we have the training set. You get the word embedding representation of every word of every sentence. Pass it through the input layer, you get another representation, and there will be a set of hidden layers in the neural network, right? In CNN also. So there will be a set of hidden layers. So hidden layers will give you representations like the 4-dimensional feature representation that we have just discussed, that are typically passed to a softmax for the classifications. Now in our case, after learning from the hidden layer representations, rather than passing through softmax, we classify through a support vector machine. The reason of doing this is that compared to softmax, support vector machine is a more stronger classifier. So we wanted to see for this particular sentiment analysis problem, whether this will be effective. Now, not only this, but in addition, we also have done this particular direction. If you see, there is a written multi-objective optimizations and optimized features. So these are the classical, you know, that SVM is a classical machine learning algorithm. Now what we did is that from the training set, we extracted the handcrafted features. We also build a feature learning based, feature engineering based, classical machine learning algorithm based on support vector machines. We extracted the features from the n-grams, from the different lexicons. And then there we employed a feature selection algorithm. The feature selection is done using these multi-objective optimizations that selects the important features with respect to an SVM support vector machines. So those features, you can see, those features are concatenated. That means these are the handcrafted features. Select the important handcrafted features using multi-objective optimization-based techniques by optimizing the accuracy and the number of features. This is, I'm not going into more details, but this is a very effective feature selection algorithms. And then it identifies the relevant set of features. We concatenate these along with whatever we have learned from the CNN. So this is the CNN intermediate representations that we are getting from the hidden layers, combined with learned features, and then finally we are classifying. And we experimented this on a variety of problems: Hindi, Twitter, product service reviews, movie reviews, English, on many Twitters, then product service reviews, generic tweets, sarcastic tweets, and we have also used some features like emoticons, punctuation, sentence wording to learn the SVMs. Okay. And finally, we see that for English and Hindi, for different kinds of problem of sentiment analysis, this particular method was found to be promising. So now, then after doing that, we focus towards the recurrent neural network. I'm assuming that you know recurrent neural network, so I am not going into much details of that. But in recurrent neural network compared to CNN, the difference is that in RNN you can learn the temporal dependencies at every point, right? So you have the input like this, you have an output, and you have a kind of, let's say, set of hidden layers. Okay, so if you expand it, if you expand this particular unfolding, then you get a situation like this, unfolded network. So W as an input, let's say ST minus 1 is just a hidden state, ST is another hidden state. So at this point of time, at time t, the activation function that with respect to this hidden state, if we denote it by AT, then it will depend on the previous hidden state, right? ST minus 1 into W is a weight matrix that has to be learned through learning. XT is an input. Again, U is a matrix. So it depends on the current input, previous state, and then you apply tan H on this AT, and then the final output will depend on this ST and another weight matrix V. And finally, you classify it. The PT will be the softmax over OT. So this is how the RNN works, right? So now RNN has different variations also, and it has been used for solving many sequence learning problems. One is the part of a space tagging problem. For example, in this case, given a sequence of words, you have to classify it, you have to annotate it, whether it is determiner or a noun or let's say JJ, adjective, etc., etc. For sentiment classification, what we do here is that if you say that zoom and display are awesome, so you learn a RNN, right? and then finally we are classifying, and then we are getting whether it is positive or negative. So now, like fuse tagging, everywhere we are not trying to classify. So rather, we transfer the information from the first point to the second, from the second hidden state to the third, third to the fourth, and finally this captures the whole information, and then we are classifying whether it is positive or negative. Then it has been used for many applications. You know, the machine translation, part of speech tagging, in-ear, image captioning for variety of computer visions and natural language processing problem are used. So I'm not going into details of this. I'm assuming you know, but with respect to sentiment analysis, let's see that how can you use this RNN now, particularly for aspect-based sentiment classification, not the aspect extractions. I'm going to talk about one of the work like this, which is based on long short-term memory, which addresses the problem of RNN. The problem of RNN is the long-range dependencies, right? It cannot capture the long-range dependency because of the vanishing gradient problem or the exploding gradient problem. So LSTM, through its cell state, it has the capability to forget the past, right? So LSTM can learn the long-term dependency. And now there are different variations. Let's say in this particular work in 2016, what they have done is that they came up with 3 different models. What are the models? Let's say there are two, this particular sentence, review sentence is given to us. Its battery is awesome, but camera is poor. Now what a RNN or LSTM will do? We will represent the word embedding of each, then battery, then is, then awesome, then bar, then camera, then poor. That we are doing one after other. We are passing through the LSTM. We get the hidden state representations. We go on like this. And finally, from the final hidden state or final LSTM, you get a hidden state representations that you pass through a softmax, and then you are getting positive, negative, and neutral. Now, if your target is battery, then you say that it should be positive. But for the camera, the polarity should be negative. But whether the target is your battery or the target is camera, whatever may be the case, you are following the same process. There is no difference in its operations. But actually what we should do, we should learn in such a way that if it is the word battery, then it should learn in a different way. If my target is camera, it should learn a different way. Right? Because for battery, it should be positive. For camera, it should be negative. So you have to provide 2 different kind of representations. But how can you get that? So now, let's say rather than one sequence of LSTA, we maintain 2 LSTM. They have maintained 2 LSTMs in this case. That one learns from left to right and the other learns from right to left. So if your battery is the target, then you learn all the words, the whole sequence from the beginning until this word, target word, by the LSTM-L, the left side LSTM, and starting from this target to all the right sequence, you learn using a right LSTM, another new LSTM. So how it is learned, let's say this one, so the left LSTM you learn up to this, and right LSTM, let's say port first, and then port to ease to camera, camera to BART to awesome to ease, and then finally you get HL plus 1. So you see that left part will be a kind of its battery, and the right part will be port is in the reverse direction. Port is camera, BART, awesome, ease. And then you combine them together, whatever you are getting from the left representation, whatever you are getting from the right representation, concatenate them, and then you classify. Why it makes sense? Because if you look into the now second aspect, which is camera now, you see that if battery is your target, then your left sequence is very smaller. But if camera is your target, then the whole left sequence is more longer. So it will be now its battery is or some back camera will be learned by left LSTM, and only camera is 4 will be learned by the right LSTM. And you see, these two representations are not similar. But in earlier case, irrespective of whether it is battery or camera, the whole representation was same. So now we can say, as now we have different representations, and this representation is known as the target dependent representations. So it will be more effective in doing the classifications. We can make it more effective if in the left LSTM when you are learning, if every time you at every point, at every time period, if you let your RNN network know what is the target that you're trying to learn. That means if your target is, let's say, battery, the battery will be V target is the word embedding representation, that is the battery. And you see that is combined with every word. That means when you are getting a presentation of W1 free and LSTM, you are in a resource poor language. One, you can do that, okay, everything you can translate to the machine translation, all Hindi or Bangla or Telugu, everything you can translate to English, and then you can use all the English resources. That is one way. But it has been found if you translate a document from one language to the others, you'll find there will be loss of information. Okay, the adequacy of in the target side will change. Fluency sometimes changes because through translation, because the translation is not 100% accurate. So that may not be a very viable approach. However, people have already done for multilingual sentiment analysis or cross-lingual sentiment analysis. People have followed this kind of methods. In our case, what we did is that we did not. We get a kind of concept of cross-lingual embedding, and through the cross-lingual embedding, we get a representation for the Hindi word into the shared embedding space. So what is cross-lingual embedding? Word embedding, probably all of you know. The cross-lingual embedding will give you a representation of a word that you can say that where the multiple languages can be shared together. It is a high-dimensional representation where more than one language are combined together. Okay, so this can be one of the way of doing the sentiment analysis. And why out of word vocabulary problem in multilingual? Because let's say if you take Hindi, and then you'll see that if you train it is useful to bridge the language